In a world that walks the line, there's a rare few who think outside the box together for the crew. To break the equations, not bound to any rule. Exposing to the world the universe's own view. It takes the talent of the craftsman, it takes the mind of the fool, to make the vision realize energy and matter in a duel. To a break, to a duel. The old man, bills was running through his head. Cheryl probably got it hiding under his bed. Penny up to Annie, making power for days. Don't listen to a word that the straight dope says. Mike building batteries that power a ship. Victor comes and talking math, that's the water spiral dip. Sean chucking plasma volts a mile long. Sheila on the video making tone chuck the prongs. Burning breaking matter, they said it couldn't be done. And to all the people in the chat, I know you're having fun. So it's time to spend your Saturday with the dope and old man Bills.
Hello, everybody, and welcome. My name is Nathan, otherwise known as Old Man Bills. Joe, Sean, what's up, guys?
It's great to be on. It's a surprise visit presentation. It's more of an inspection, Nathan.
More an inspection. Sean's finding out if I'm doing my job.
That's it. Yeah. We're being audited, Nathan. That's it. We're done. Sean, it's awesome to have you as always, bro.
Thank you. Yeah, this is a reality audit, okay? And we're going to see if you can pass it.
Oh, my God.
So I'm ready when you are, Joe. Great to be here, guys. It's kind of, we went kind of from 0 to 100 miles an hour here. I wasn't planning on this, but as Nathan and I were talking, there's a window where I think I have enough brain power to share with you guys what I'm working on. So this is all last minute. And thank you, Joe, for letting me step in your schedule here on your awesome presentation. But hopefully we can do both tonight.
Oh, yeah. We'll get it together, and what you're going to show and what we're going to talk about, it all ties right in together as always. So
Awesome.
The floor is yours, Sean, and we're looking forward to it.
Thank you so much. I appreciate it. Let's see. So I need to make a few apologies here. One, I'm losing my voice. And two, my slides and videos are not in any order. I just dumped what's interesting the past couple days, and Nathan thought it'd be cool to share. So I'm just going to share what's going on. So this first photo, actually, I did as a snapshot, a screenshot. We'll see a video of it shortly. But I just did it as a placeholder, but as you look at it, it actually has a lot going on. First, I'll explain that as in all of my RAV experiments, the wire you see coming from the top there is the anode, the bottom there, which I'm using an aluminum heatsink. That's the cathode, and then in between you have the glass tube. I'll have a few drops of water to kind of kick things off. And then I'm running between 30 and 60,000 volts DC. That's the setup. 10 milliamps is the maximum. This is very dangerous, actually, voltage. You definitely don't want to put water on it or near it, but I have water all over it because I believe that simulating lightning or nature, you can actually just see some of the effects. And so, for example, after a few drops of water here, you're seeing that two RAVs form. You'll see that there's these, looks like parentheses here on each side. These actually move out. These light beams, I guess you'll call it, move out. Almost like you're seeing, a diagram of sound, how it kind of moves out. That's what's happening here. So I have that video later. It'll be fun to dig into. But this is more of a placeholder. So we'll get started. This was my first experiment of what I'm going to call Calderon streaked filament morphology. And so the reason why I say morphology, because I'm not describing new plasma physics, at least yet. What I'm talking about is that the forms of plasma I'm going to be sharing with you, this is one of them, they're not found in the physics, plasma physics literature. At least AI could not find it, and begrudgingly AI gave me the pass to say that this is a new, this filament, streaked filament is new. But here we're not seeing the streaked filament yet. But here's the new RAV that is also associated with this new filament. So you'll notice that the RAV is more like a donut shape. It almost looks like a little UFO, and it starts from the bottom and it kind of works its way up the glass. This is a completely new RAV in a number of different ways. One, of course, it's the shape. It resembles that UFO kind of shape there. It's also very dense. Normally, if I look at a RAV from different angles, it almost has sort of like weaker spots of it, even though it's still a circle. This thing is fierce, steady, strong. The light from it, you can't tell here, but it's a piercing light. And you'll notice that it leaves like this red trail. That's molten glass. So RAVs usually will paint a beautiful little fractal structure on the glass tube. You've seen that before. Not this little guy. Excuse me. Sorry about that. This little guy melts, turns it red hot, melts it molten. You can see that. That's just molten. So the first two thoughts I saw when I looked at this was, one, it has this unique shape, and two, if I could run it up the glass, it would probably cut the glass. So interesting. We're just on the cusp of learning what that is. Nathan and Joe, did you guys want to jump in with questions now, or do you just want to go to the end and then ask questions?
Let's do them now. Go to the point right before you drop the water in.
Okay.
I just want to show you something, because I've seen this a bunch in your work.
I'm not sure when you mean
just before you'll see the dropper come in the top. Just let it go. Let it keep going.
Oh, from the top. Oh, wait.
Play it through.
Oh, that's right. It's at the end. Okay.
No, I got to go back just a bit.
It's right here. Is that the water drop?
Go back from it. I want it right before it.
So there's no water drop, but you just see the dropper on top.
Okay, you can kind of see it right here, but you can see it, I think it's one frame back from this. You see the sheath layer? You go back.
Keep going back.
Now, you see a little dot in the front. You see the round sheath layer that goes between your RAV and the bottom there. So you see the plasma.
Yeah.
Behind it, look exactly the same distance behind it, you'll see the black dot.
Oh, you're talking about in this region right here.
So it's right to the right of that.
It's right
Just
there.
To the right and down.
2 to 3 millimeters to your right. Right there.
Yep.
There's your black dot. It's at the exact same distance as the little ball in the front that's green.
Yep.
Yeah. Yep. Mm-hmm.
And you can, when you watch this, you'll see the energy exchange take place as it flows between the dot in the front through the RAV to the other side.
I'm going to have to really play with the lighting here to see that better, because now I see it. You can see that there's the layer here, and then inside here, of course, is that center point. And I don't know if you've noticed, but the color of the lens flare is very different. It's not that same.
It's because you're going through the glass. So real quick, another frame in this shows 2 little puffs of clouds on the right and left side of the RAV itself.
Yeah, let's see.
Okay, so what that right there.
I caught that too.
Right there. Beautiful.
Look at that. But that right there becomes your energy exchange, and you're bursting out energy.
Yeah.
And the clouds form on both sides where they're exactly where they're supposed to.
Yeah, those are literally structured because they pulsed out transaxial. And if you look, right, they're actually actual toruses. Okay, but they're spherical toruses that are puffed right out of the center because they're a full-blown analogy of what's occurring inside. So they're structuring as a projection of the actual structure itself, because they come out at a moment of
incredible.
Yeah, where it's literally compressed in the state of expansion emulated version of itself, structured the same way because it's still charged.
Right. And
It's interesting because you just blow right past it. I want to say thank you to Darren real quick, man. Thank you very much, brother. I really do appreciate it, my friend.
you're
Right
awesome,
on. Thank you,
Darren. Darren, you're so generous and supportive. You're a big encouragement to the channel. So special thank you to that, to your kind generosity. Say that twice. Yeah, I'm glad you caught this, Nathan, because the glass tube here is extremely hot.
Mhm.
And yet, as the water drop moves down, then the steam comes out on those structures, as how were explained by Joe. So that blew me away because I'd never seen steam do this. I've never seen something hot have two formed objects go to the place where it's hottest on the inside, but not necessarily as hot on the outside. So that's
Well,
so there's a lot of field
Well,
action going on there.
I want to kind of maybe tweak this a little further. It appeared that the origin of that steam or smoke discharge was from probably inside the tube, which if you want to really hurt your head
Whoa.
about things,
Yeah, wow.
okay, I mean, you follow, it's not, the RAV is inside the tube, the drops were inside the tube, and they were emitted through the tube.
I don't think they were emitted through. I think they went over the
Yeah.
top, Joe. You could see the line coming.
Did they? I don't know. I would need the
Well-
context to that, but you could see how they're structured like yin yangs. I mean, look at the one on, especially on the left.
Yeah, no, I definitely agree with like kind of eggs forming into a ball.
Yep.
Dude,
It's a rolling layered sphere, just like the RAV is.
yeah. I'd like to point out one thing, Sean.
Sure.
Take a look at the colors coming off of this thing. You got green in the center, right? But then it goes to a lighter green. So you have that specific green in there. When you have the purple to black look that shows up in any time in a RAV, you'll start to see that specific bright green. There it is in the core. On
Yep.
the outside, you can see the purplish, blackish color.
Yeah.
Okay.
Yeah.
That's when it's telling you it's breaking the UV zone right there.
Mhm.
Okay. And then just roll this back a couple of minutes. I want to see where the actual smoke comes from because I think it builds on that layer when it pops out of the top.
Well,
Joe says it
also
comes
take
through.
note before you move on. Oh, you moved on from it, but if
No, it's okay.
in the
It's
last
okay.
thing we just looked at, there was central coupling going on too. So yeah, okay, cool. You're back. So
Good.
look at the central coupling that's going on with the smoke. You know,
Oh,
you
I
can
agree.
see it's directly relative to the RAV itself, the
Yeah.
flare, and the two puffs of smoke.
Exactly. All the field action, drop action is all right here. And again, this whole thing is hot. When I put it on the infrared, it's almost all the same heat.
Oh, hold
So-
on. I know what you're doing. It just occurred to me. Hydrogen and oxygen. Oxygen's flammable. Hydrogen's flammable. But it's only when you split it in water do you get this effect, right? So we're
Right.
seeing the RAV is normal. It's very small. He hits it with the water and then it flares out, right? Like it got an extra boost of energy.
Yeah.
He broke down the hydrogen and oxygen, you know what I mean, from the H2O, and it exploded the RAV. That's
Yeah.
what he's doing.
I mean, to throw it out there though, oxygen is not actually really flammable. You know,
It explodes though, doesn't it? If you have pure oxygen.
if you have something to burn, yeah.
Well, you're putting it inside of a RAV. I mean,
Well,
you're
yeah, I
literally
mean, it's the hydrogen component, so obviously it's combustible under those
through
circumstances.
hydrogen, yeah. So I'm just saying, I mean, if you look at it, that's exactly what it looks like it's happening. It's exploding inside the RAV, that you're splitting it and it's exploding it.
Right. No, it does. It does. I have a video of the colors of oxygen, which will be pretty cool with the electrolysis here in a moment. Good
Yeah,
stuff, guys.
I just want to tell Magneto Frico, this is the cold plasma version. We're not even close to hot enough to get hot plasma yet. So
Yeah, I mean, right. This plasma, it's probably that hot in the like toward the core, but you know,
I think
if
it's
you
cold in
know-
the core.
I mean, it could well be
That's-
cold. I mean, I don't know. I think the way that the differentials play out, it's probably right outside the core is the hottest, right next to it being the coldest. I think that the separation is really that you know, but
Yeah.
neither here nor there. I mean, the plasma is not hot. It's not hot enough to melt the quartz glass.
No, no.
No.
I think because they come in as the energy exchange show through the RAV, it has to be cold on the inside so the outside can be hotter. You know what I mean? Because you get, you know what I mean? It has to have an exchange through entropy in order to do
I
it.
agree. I agree with that. That's the foundation.
Good stuff, guys.
Anyway.
Good stuff. All
Sorry,
right.
Sean, we're breaking down everything for you.
No, that's great. That's great. All right, this is the one I was telling you about. So what's
Look at
occurring
this.
here is this is a quartz tube, glass tube, and it's about a 1/2 inch in diameter. It's about 1.5 inches long. Maybe you'll see it later, but this tube is filled with about a 1 inch of water below here. And so what's interesting is because it's quartz glass, it won't interact with the heat of the plasma. The plasma is not hot enough to affect the quartz glass, as what you saw in the previous video was boresilicate glass. So you saw the RAV just sort of climb right up that glass and leave a mark in it. Whereas here, the quartz glass won't let it happen. And if I have a clearer shot below here, this water is boiling with electrolysis. Now it's also boiling because of heat, because under high voltage plasma, water boils at a lower temperature. So you're getting both of those things. So I did a little research on this color. What is up with this blue? And this is just a quick analysis. I just discovered this last week. It's all new to me. Is that the blue is coming from because there's some oxygen here that's being taken up in the plasma streamer and a little bit more dominant in form.
This is one of the most incredible things I've ever seen. Whether it's useful or not being secondary, because it's not useful. Okay, but what it's useful in doing is showing you what the energy exchange exactly looks like, because that's what you're seeing. You're seeing the current from the arc, that has a directional propagation. It has that directional propagation down toward the cathodic side. Now, the asymmetry proportions are not proper and constructed enough. It's pulling, and it's overpowering the cathodic energy and pulling, and it's at a high density. So it's actually pulling that cathodically charged gas, that negatively charged gas, into that stream in the energy exchange, creating a reverse flow.
Oh, wow. Do you want me to kind of go through a few frames and kind of maybe explain kind of what you're saying?
Just number one, you got the green at the top already. Okay, slow it down.
And that's how you know that's exactly what's happening, because
Yeah.
the equilibrium is only being established or on the anodic side of the bias, right? So you usually, if we're going to form a RAV, it's got to be much further down onto basically the cathodic surface. But in this case, it's actually pulling all that excess cathodic energy right up,
Okay. I want you to notice something. From bottom to top, it's swirling around the color in the center. Take all the yellows, okay, and all the oranges, and they're swirling. Stop right there. Stop.
They're right there. They're right there.
You can see the swirl, okay?
Sorry, I'm not touching it. It's delay.
So hold
Is
on.
that okay?
We always talk about a wire and things going around the wire. Nature doesn't work the way we think it does or see it in our head. It works like this. You see the energy go around it, then you start to see it heat up. As it heats up, you get to the yellows and the oranges, right? Other than that, it's in the purples. So it's not until it gets a heavier amperage in there, caused by the stuff you're putting into it, to see the swirl. So this is actually how energy works around a wire, but we're not seeing it that way when we describe it or see it in our heads, but this is the way physical energy moves.
Yeah.
Right. It's using it as it's using the anodic bias at the high density level as a conductor of the cathodic side. It's literally acting as a carrier wave conduit, to return, and it's probably using like some form of anodic like laminar flow, to skirt up the side rather than mix, which is the same as the rab formation. How they skirt along the sides of each other, creating layers as they
Well, I would say the purple's the laminar flow on the inside, and the outside
exactly
is the break of it.
dead on. Yeah, exactly. And you could see how it's like reverse flow. You get all that negative charge state just riding right along the surface like a carrier.
Hmm.
Absolutely phenomenal, because this is everything that we describe, and now you see it with your eyes.
Wow,
Oh,
that's
look at
amazing.
that! That looks like a seahorse.
Mhm.
Sorry.
It's great, guys. Thank you. And for those of you who are just coming on, there's a quartz glass tube in front of us, filled with about a quarter inch of water, tap water. And then on the top is the anode wire, and the bottom is the cathode. And it's running about 60,000 volts, 10 milliamps, around 600 watts. And so this is just the physical description here, but Joe and Nathan explained a lot that's going on here. I introduced a little bit of carbon, microscopic carbon that's picked up by the plasma, and then it causes these little cool streaks inside the streamer. So that's kind of what the new discovery is that these little streaks, these little guys, filaments, are sort of giving you a view of what's going on in this discharge. And someone asked in the chat about, isn't quartz glass borosilicate glass? Well, quartz glass is a different combination of glass that takes it's less affected to temperature. Borosilicate glass is very sensitive to temperature. So if you look at some of my videos, you'll see a lot of cracks in the glass tube. That's borosilicate glass. And then if you see tubes untouched like this, then it's the quartz glass. I'm not an expert on quartz glass. Maybe Joe can give a better definition of quartz glass.
Sure. Quartz glass is made of quartz sand as opposed to oxide, like lab made oxides, and it maintains some of its lattice structure, but it's an incoherent lattice structure. So it's not the same as quartz crystal, where quartz crystal is a repeating lattice structure, whereas quartz glass, is its lattice structure at the at the macroscopic level, but not throughout the whole material itself. It's broken up into whatever remained from the melting of the original mineral. And it's non-piezoelectric, by the way.
Oh, it like quartz is piezoelectric. This isn't.
Correct.
Interesting.
Because it doesn't have the structure.
You're right. It doesn't have the repeating structure to get to the level, where the pressure would,
Interesting. Wow, thank you for that, Joe.
Mhm.
All right. So we'll go to the next video. I think we could probably stop at just one video and the whole night, huh? It's so much to learn here. So this I posted as a YouTube short on Nathan's channel. I thought it'd just be fun to show you guys. No, this is the borosilicate glass, and you can see the tube here has a lot of cracks in it. And that's because when I add the drops of water, the glass is at one temperature, but at one point the water hits the glass, it changes temperatures drastically, and then it causes this sort of pulling effect on the glass structure, and it causes it to crack. So when you ever see the tube look like this, and it looks sort of sci-fi, weird, it's just the glass tube with cracks in it. I don't use camera filters. I don't use anything. So what you're seeing here is what I see with the naked eye, except for it's just probably a little prettier. What's unique about this is that I put it on a very strong N52 neodymium magnet sphere, And if you've seen my other RAV videos, the RAV sort of transitions from this bluish purple to a yellow to an orange, then to a white, and then boom, you reach coherence. With the magnet under here, you never really get the RAV coherence. It seems to stay purplish blue at the bottom of the glass tube on the magnet here. And doing a little research, one of the things that I caught my eye was that it talked about electron paths being stretched. And when electron paths are stretched, it sort of doesn't allow the plasma density that you see in the yellow and the white. But that's what I looked up. I thought this would be interesting to share, and I'm totally interested in what you guys think about this one.
Play it slow, Sean, if you can, and then just pause it every so often. I'll tell you when to stop. There's a specific thing I want to show you.
It stopped working here. Let me see if I can get it working again. There we go.
Okay, you see when the yellow and the purple are tied together between the yellow line that goes in between them? Right there.
Mhm. Let me see it. This guy's acting up. Oh, I think it might be. Okay, is that good?
Okay, yeah.
Okay.
So right there, you see the purple on the bottom, and then right up above it, you see the purple transitioning into the yellow.
Mhm.
That's what we're looking at when we look at amps and volts. The amps have a lot more heat in them, so they are the orange. The voltage is purple. So it shows you the difference between the two. So when you say that we have a certain amount in the frequency that we're dealing with, right? Certain amount of amps, this is what we're talking about. So you can see the amperage layer in the orange, and then you can see the voltage layer in the purple. And you see a combination between the two different layers, right? And that's what's creating the energy right there. So we normally think about it as, hey, I got two spheres, and that's what's connecting my energy, but that's not the way nature says it. Nature shows it just like this. So as we're looking at this layer, just imagine that rolling around a wire, and that's what you're looking at right there, right? You have a hot layer and you have a cold layer. Now, depending on how much you put in each of it, that's why I tell you the frequency balance is where you need to be. That's why, because you'll see the exact transfer right there.
So, you can also see that as, because of how the energy is being transmitted, it's hitting a choke point, right? So it's hitting a much higher level of resistance, after the discharge from the anode, and the energy exchange, again, being an offset differential, has, a bias in this case, where the cathodic energy is traveling as a carrier in this case with it, and it's hitting resistance as it hits that narrow part of the anodic arc filament, and vice versa. The anodic arc filament is also choking down and hitting resistance as it travels with the glass. So for that reason, then you end up with, the amperage, the hysteresis, right? And just in general.
Well, kind of look at it like a high voltage line, right? How do you get the high voltage line to go from high frequency, high volts, and then turn into regular usable energy for your house? You basically have to put it into a 3-leg transformer. You're going to put it in mineral oil, which compresses the entire thing, creating a ton of heat, which then takes all the lines that go in, the vector lines that go inside the transformer, and aligns them to give you magnetics, right? But this is the same thing. You're creating the compression in a different way inside this tube.
Yep.
In order to pull this off, but it's the same effect.
There's
no difference in it.
And it runs on the same dimensional scale too. So
yeah,
when you start getting to like the more stable geometries, it's because the dimensionality of the magnetism has increased. Where this is just running at a straight current type magnetic component. And the thing, and it's less apparent in this particular photo, but in many of the other stills that you were just showing, it's much more apparent. What's important, that you notice is still that it maintains the structure between hot and cold, right? And we know the difference between the UV spectrum and the IR spectrum, and how that once it falls into the lower frequency bands of the IR spectrum, you're dealing with heat. That's
This-
exactly what it is. And
it's
once it
interesting you
goes to
say
that
that.
heat side, those are losses, right? We've said it 1,000 times before. Out of any type of energy, you could turn sound into
Just leave it
current,
right there, Sean.
right?
Oh,
You could
my.
turn sound into current. You could turn light into current. You could turn current into magnetism, and everything, whatever. But once it's in a heat state, it's in a state of waste and diffusion.
Mhm.
That's it. Period. There's no reclaiming that heat to restructure it in a way that could return back to the current state.
That makes sense. Nathan, you said back it up a bit.
Oh, you're creating different forms in here, and some things show up better than others.
Okay. Do
So
you want me to
that
keep
was
going?
it.
This is
No,
it?
no, you're okay to play it, Sean, if you want to. I just was trying to. It had a very specific signature to it.
Oh, sorry about that. I think I
Oh, stop it right there.
Okay.
No, that's not it. Sorry.
Oh. I see this one.
No,
Sorry.
that's all right.
Hey, can I say something real quick? Because this is just it's pretty profound, I think.
Go ahead.
Yeah.
We say, right, that heat, okay, is material in a high state of excitation. Okay. However, we measure heat in that high state of excitation on the low band of the light spectrum as far as frequency is concerned. Do you see where I'm going with that? It's because it's not the material in the high state of excitation. It's literally the remnant of the material in the high state of excitation. And it's in a state of dropping in that, in that high state of excitation through diffusion.
Well, yeah, the color has more amps in it, so it would have a longer frequency.
That's exactly what I'm saying. Longer frequencies, lower frequency.
Yeah.
Longer
Lower,
wavelength,
yeah, down to
lower
hertz, stuff
frequency.
like.
Correct. But they say that for something to exhibit heat beyond ambient, that it has to be in a higher state of excitation. Do you see what I'm saying?
Yeah, it's
So
the
So
opposite.
it's in a higher state of excitation, but somehow the frequency bandwidth is lower.
Oh, hold on. They say excitation, meaning that it's more visible to the naked eye, but it doesn't mean it's in a higher state of energy. You get what I'm trying to say? Because the higher state of energy is a darker color all the time.
Mhm.
It's the loss of light that gives you a higher state of energy. When you see all the light, it's a waste. So, but to our eyes, we think it's the higher state of energy, right? Which is why they say the word excitation.
Mm.
It's backwards and confusing. They should just say it the way it is. When it produces light, it's losing energy. When it doesn't produce light, it has a ton more energy.
Well,
Should have just made it simple.
I mean, the whole thing, though. I mean, and I'm not trying to use words, out of context or something to try and justify my take on the matter. But as I've said it a bunch of times, I feel that heat is actually the signature, okay, of material being returned to a pure energetic state, meaning that the material is dematerialized, okay, and the signature that's left behind, okay, is heat. Now, if you think about that and then you pair it up with what I just said, in order to remove the material to a higher state of energy, added dimensionality, right? It would have to be in the highest state of excitation to leave, but then the heat that's left behind is at a much lower frequency. So the whole point that I'm making is that it's both true at the same time. And it's that the way that I'm putting it is actually the only logical way for it to be true. Because something that has to be in such high excitation, right? But then measures so low, where's the break in that logic? You see?
Okay, hold on. But if we look at a wormhole and we go back to Sean's previous video, right? And it showed all the swirls that he did on the outside. that's actually how it would look. You see them on the outside? We travel not in the purple of that, but inside the purple of that, which is the higher state of energy, which would be dark. It would just be black. You know what I mean? To us. And then the outside of the purple would begin the energy, and the outside of that would be that. So that's the formation pattern of the wormhole. But the inside center would be just black because it's the highest state of energy. That's what we're crossing through. It'd be no use to getting to the hot side because we just destroy ourselves. We couldn't live in that. We need the vortex and the core of it to pull us through. Otherwise, it doesn't work. It's a Schauberger. He's creating the vortex in order for you to pull through the center of it. The hot parts of the energy are no good to us.
I'm taking good notes here. Yeah, you made a good point. Bunch of good points, guys. Good stuff. All right. I think
Ooh, what's this?
I thought this one was interesting because when I would add a drop of water to the plasma, it wouldn't fly out sort of in, you would expect. You pour water on hot water on a campfire and the water just sort of randomly splatters out. But I asked AI to just add a little tail to all of these little splashes. And stuff's buggy right now. So let me show you again here.
That looks like welding.
So can you see how the water droplets, they're not following down. They actually start to try to almost orbit the thing. You can just see that they're just traveling around. I see this with the naked eye, but I had to have kind of asked AI to make a little tails. It's funny because AI did this once for me, and then AI now has amnesia and can't even imagine doing this. But I thought I would share this. It's interesting. Maybe get a good picture. So these are paths of water drops that come straight down. I can't help to think that they're being electrically charged, and then now they're becoming part of the
Do not change this frame.
It's exactly what it is. I mean, without AI even having to intervene, I was able to capture exactly this phenomena in that the quartz blowing apart video, just by slowing it down enough. So it's there and it does it. And it's really, really incredible. It proves out the whole thing and shows you the geometry.
Okay, Sean, now change the frame.
Yeah,
there's a giant carrot-looking thing going right down the center of it.
Carrot-looking thing going right down the center of it. Oh yeah, I see this. Right. A carrot-looking
text or something like that. Looks like a giant carrot.
It does look like carrot.
Do you see how the smoke has sort of, it's like sliced here and it changes colors? Isn't that interesting? It's almost, and then look at the smoke here. Maybe it's just because of the effect that I asked AI to add. Maybe that's it.
I got to be honest, it's not though. I don't think, because what you're seeing right there in the center plume is you could see the transaxial discharge of the rab itself in that case. And you could see how it's structuring the smoke toroidally, like classic donut toroidally around the exterior. This is all key points for people to hear. The torus is happening, exterior of this three-dimensionally. All right. The greater scheme of it is toroidally spherical. But the outer fields, because it's subject to a different locality, it's not part of that inner force of the rab itself, that forms as an actual torus in that case. And you could see a transaxial bifurcation of the smoke right at the equatorial plane. And where you see that little plume kind of escaping out the side, that's actually something that we observe continuously in like the magnetosphere, and something that we've discussed also, how that's tied to the lens flare. That little offshoot right there that you wouldn't typically see is an energy reservoir, that fills the eddy currents that exist outside the toroidal plane of the reach of the rab itself. You can see the repeating pattern in the plume of smoke that's directly above the RAV and that initial donut itself. It's
Yeah.
just simply repeating in diffusion.
You can see the donut right here starts to just sort of form. This is almost like a donut right here. If you can see
Well, that's
that.
what I'm saying. That's exactly
Yeah.
it. And then if you look above
Yep.
it, you have another.
Yep.
And then
Yep.
if you look above
exactly.
that, then you have another.
They're
Yeah.
more infused, but yeah, I can see it. Yep.
Well, and it's more fused because it's in diffusion at that point. The field geometry is changing. You're now getting the field geometry of the anodic side of the reaction as opposed to the coupling side where the RAV resides. And if you notice the absence of it low, well, that's not ironic either. The geometries are down there too, but they're repulsive, which is why it's pushing away. And you can see it all pushing away. So the cathodic side is a repulsive force to the charge of the smoke.
Interesting. Good stuff. Good stuff.
Then you can see the spin in the smoke.
Yeah, and you don't see. I mean, the raindrops caught my eye. Raindrops, the tap water drops, caught my eyes. That's really inspired me to run the simulation. But thank you for all the extra detail, guys. It's good stuff. I'm seeing it now.
Mhm.
So I was trying to get carbon to add a little carbon to the experiments, to the RAV experiments, in order to see if I can eject plasma and be in some kind of ball lightning state. I failed the experiment, but I always film everything, or video record. And so I came back to see if there's anything interesting. And this was the first video that I had taken. And I just thought to myself, this is not a failure at all. Oh my goodness. This is actually something that just blew my mind. And so this is something I'm now working on to kind of perfect, meaning that you can get a lot of detail. You can dig deeper into this action that's going on. But you guys saw this earlier. Yikers. Stop this here. Come on, guy.
Hey, Sean, can you clarify in the last video the AI portion, and then on this one, which one's is it ferrite you're dropping in there, or carbon you're dropping in? Because I want to make sure you make a distinction.
This is a glass tube. I put a few drops of water on the RAV itself, and the water droplets get charged, and they create these sort of they swirl around the glass tube almost to orbit it, versus water droplets should be, dropping. Now you would expect them to be flying in all directions because it's hit a very hot source, but in effect it charges those droplets and they begin to change direction. And then there's some cloud action going here that Joe mentioned earlier about how there's forming these cloud toruses. As they get diffused, they get bigger, and they get bigger. So that's the phenomenon there. Nathan, the next video now.
Hold on a minute, Sean. I just want to clarify. So he asked AI on this one to add a streamer to the end of the little dots flying. So that right there, the little dot that goes around is normal. The streamer that comes behind it is AI. But on the other one, when he's doing it, all the little lines that are coming off in red and orange and yellow are not AI at all. I just want to clarify that.
Yeah, good point. Yep. These
this is just video enhancement so you can see it more clearly what's happening.
But you want to identify which one's which so people don't get confused, because I got confused.
Yep, these are water droplets enhanced by AI, whereas these are actually individual ionized carbon molecules that Nathan and Joe will explain better than me. But let me see if I can get a really good shot. But it's the same setup: anode on top, cathode on the bottom. This time I'm using a paper clip. This is a quartz tube. A glass tube has a different reaction. I just want to get a really nice plasma shot here, if I can. You guys can explain. This was my sort of first introduction. So many pretty, which one's the... So normally in plasma, which I'll show you some pictures, it's just this beautiful sort of solid looking, fuzzy, solid and fuzzy, purple sort of arc. But introducing these carbon molecules, they get excited within the arc and they take on their own little trajectories, densities, and field interactions of their own. So there's no water in this scenario other than to kick it off. This is all little carbon molecules getting taking paths based on the geometries.
Yeah, it's quasi-galactic in its nature. If it was just to actually go, full rotational while remaining on a 2D plane vector, what you'd end up with is the energy condensing, and then the material separately condensing, and then organizing as it all spun around, and it would literally be the equivalent of having suns and planets and gas in between as it spins, and you could see that arrangement, as this goes. And I don't want to change topics or get too far off Sean, but I just want everybody to understand, at least my opinion, and if there's disagreement among Nathan and Sean, I'd love to hear it too, but the importance and nature of and role of water in this context, okay? Because it's actually the same as the context of the water in the original RAV configuration. All right, the nature of the water, okay, is to add an excessive amount of capacitance potential, okay, while at the same time allowing the energy to start to concentrate, at a much higher, a K value, right? Your dielectric K value, and it's able to reach that capacitance in containment of a dielectric material, okay, for much longer, allowing for the saturation of the dielectric. All right. That's how you get the stability, is by introducing the water as the intermedium for the concentration levels to get to the point where the dielectric breaks. Because it's the dielectric breaking that leads to the asymmetric exchange.
That's a lot to take in.
Yep. Marinate in that one for a minute.
Yeah. More than a minute. Yeah, thank you, Joe. Nathan, do you want to add to that?
No, I think Joe nailed it.
Yeah, I agree. There's something that peeked over in the corner here real quick, and then we'll go to the next one here. Let's see.
Yeah, it's cool just to pause each frame and take a look and see what goes on in every one of these videos. I like to watch these things in slow motion.
I do too. This is 20% speed. The other ones I had AI slow it even more. So this is like 20% speed right here. This is me sort of figuring things out again. Got some really neat reactions. Let's see if I can. Yes, I can do this. Okay, so this one really goes for it. So I thought, I'm learning how to really create these things super thick, super interesting, as if they're not already though. And of course, everyone I'm freezing on looks horrible. That makes sense. This might be, yeah, I think I grabbed the wrong video.
Wow, it's all over the place somewhere. It's focusing the light.
Yeah, and I got one of those ejections, those little plasma worms. I hope I can get it again, because that was kind of my intent, was to get the plasma worms again and see if I can direct them and get them to fly. Oh man,
Mm.
I'm sorry, guys.
No, you're good. I just wanted to point out that the little light, you see the little green light that comes in there? Sometimes it shows up at the bottom. Sometimes it shows it right at the top right now.
Yeah, yeah.
You start to,
Excuse me. I
and
can
you start
get
to see that everywhere.
maybe 20 of those lens flares, little green guys, which are representatory of the ravs that are going on inside, which is really, I mean, focusing on the lens flare for so many experiments has helped me because it always tells me where the rav is
Mhm.
and what it's doing. So let's see. Wow, some spectacular shots in this one. I think I have a different. I think that one's same. So here I just had different plasmas. So I'm pretty much done. I'll go through a couple of these and get your guys' thinking. Um, so this is a glass tube, and I'm running the 60,000 volts. So it's about 1.5 inches, 2 inches of glass tube here. It's about a 1/2 inch in diameter. This is one of the early phases of the plasma when I introduced amorphous carbon. Amorphous carbon is you can get it by like burning sugar. It gives that sort of black carbon. I think it's the most prevalent carbon in the world as carbon as it relates to carbon. But these red tendrils inside is unique to this, and I thought, well, let me pull this in to get you guys thinking because I love the red, and I seldom see this kind of red, and so you can kind of see that it has maybe a typical type filament, plasma filament, but that color, where's that red coming from?
I talk a lot, Nathan. You could have a stab.
Oh, I'm sorry. I'm looking at it and I keep looking at the bottom to see if it changed color to blue. I can see all the purple, right? Way below this, Sean. Go down further, down towards the bottom.
Down here,
Yeah.
I wish I could just zoom in on the bottom there, but I see that little blue right here.
Well, not
All
just
right.
that, but the lines right above it change color. Right there.
Oh,
It looks like a whitish, greenish,
yeah, it
kind of
does.
a barely a blue, like an aquamarine.
That's right.
There's some kind of change that occurs, right? And if you forget the color for a second, just use the color as just a separating indicator,
Mhm.
as opposed to actually a color difference. What you're
Mhm.
going to notice is that there's a bit of an interactive inverse relationship between the initial flow configuration in purple and the structured one in red.
Yeah.
The key point to also realize out of that too is the fact that it's structured. When something's structured, it's because it's coherent, and harmonious in terms of its resonance, and it's banding out in octaves, usually. So it's banding out because it's resonant to each other,
Mhm.
and it's entangled. Okay, so it's all relative, but it's
Mhm.
separated because it's not exactly the same.
Mm.
Yeah, that red's
So
a different frequency. Sorry.
red's a
That's a
different
good
frequency,
point.
right? Or different frequency
Good
band, yeah.
point. Yeah, good catch. Yeah, it is a different frequency.
But the flow of it, if you notice, seemed to be the same, right? The
Mhm.
direction of the flow.
Yeah.
So
Mhm.
this is not a reverse flow effect. This is an initial flow effect, which is probably why you don't see it really kicking in hard until after the arc is established.
Mm. Yeah, makes sense. This is a glass tube. A drop of salt water hits. Everything goes yellow. I thought that was just. We're gonna just
Little
look at
dancing man.
pretty.
Sodium.
Yeah. Yeah.
Sodium, anyone?
Yes. This is. I looked it up. If I remember correctly, it's a Z pinch where it has to do with the repulsion, but then the repulsion gets too weak, then there's attraction, and the repulsion because the attraction's so weak, and then so on and so forth. And it creates this design, this sort of chain design. I see this everywhere. So I like to pick out pretty ones. And so I thought I'd kind of just let you see some gorgeous shots of this effect.
I mean, it is beautiful. It's quite incredible. You can see the relationship of everything perfectly
Oh yeah.
right there. I don't know that that's a Z pinch though. I mean, that's an opinion. I don't want to really. I'm not an authority on that, but
It looks like it. So maybe I'm just matching the pattern, not knowing the underlying.
yeah, you know, the thing with the Z pinch is that there has to be that parabolic function, which means
Mhm.
that it needs to change dimensionally, right? So there has to be, like right now when you're dealing in a current state that's one dimensional, it's a point to a point, okay? And you know, once you start getting a condensate on a surface through you know, capacitance, right, and it starts to accumulate, that becomes on a plane, you know, so it's no longer vectored the same any longer. Now, in order for that plane to have a Z pinch, it would have to turn parabolic, you know, into an actual vortex, you know, and then that vortex is what goes into that state that you were saying is this crunch and pinch. You know, it goes into a state of compression, which then that compression pinches it off, and now it's no longer a tornado vortex. Now it's a spherical vortex.
Mhm.
You know, which we would probably call a fundamental particle at microscope. You know, at the particle scale of things, right?
Wow.
So
I'll have
real
to
quick,
read that.
I want to say this. I've done this before with copper. If you take copper and you take a just a pole and you spin it around there, if you look at it, it looks like DNA, which this looks like. But
Yeah.
what the difference is the copper part that I built, the pole was in there, so there's structure in there. As soon as I removed the structure, there was still the structure form in there. That's what you're looking at here. There's
Hmm.
some kind of unseen structural form that's causing it to twist around each other.
I agree.
Interesting. Good stuff. You saw that it broke the glass here. So
Yeah.
that's probably more
It's
so.
like a cannon. We're getting
Yeah.
ready to go fire.
Yeah.
Well, yeah, I mean, sodium reacting with oxygen, even in a charged particle state, is still, you know, an exothermic reaction. So,
Just gonna cruise through here because I have a lot to share. I had some questions for some later shots here, so just want to kind of when I'm a little under, well, I'm a lot under the weather. I'll just start looking through my 4K video and just kind of chill and
Oh,
check
that's
out
cool.
how
Hold on.
beautiful the plasma is. And these aren't doctored up photos. These are as the eye sees it, and just some really
Are you creating a
beautiful.
RAV in the center? Go back to those.
The
Are-
sphere.
right in the center, there's a white
there's
dot.
a reflection. Yeah.
It's a reflection of it.
Yeah, the
It's
rav's
something.
yeah, the rav's at the top.
I'm
It's
looking
just-
dead in the center of it. There's a white dot. You see it?
Yeah, that is weird because there's no light behind me. I'll say that. It's a dark room.
I think,
Maybe
you know, it could be a RAV, but it could also be a reflection, right? But here's the thing about the reflection is that because the, again, source of emission is both an emission and a receiver, any reflection that goes back into that fundamentally, it becomes a projection. So it's very
Oh.
interesting and it feeds it back. So, like, even if it is just a reflection, it's still kind of significant, you know?
makes sense.
So
Wow.
interesting.
It is. That's very cool.
I think you showed this one last week, Nathan. The plasma starts to leave.
Yeah. Now, if we could only get it to leave in a ball, spinning ball.
Yeah. I wish this was half the battle, but it's like 1% of the battle. Let's see, I got some repeats here. I think you had shared some of this last week, Nathan. I think I put it in your box.
Yeah.
Just Pretty
Because look
stuff.
at that. That right there is a beautiful shot, Sean. We were talking earlier about the RF. You could see it in yellow. You could see it in purple.
Look at the symmetry of the break.
There's a bit of delay. Do you guys see the plasma with like the 3 black holes in the lower part, the black regions? And you got you got like a little snake in the middle here, a little purple snake.
Yeah, well, I mean that's interesting, but I mean that's actually what I was saying about how it builds out symmetrically like that. Yeah, it's very interesting. I'm gonna excuse myself for 1 minute. I'll be right back.
Sure.
Looks kind of like a face, doesn't it? You have like 2 eyeballs.
It does. It does. I was going to say that. Again, you'll see my cracked glass. At the bottom here is a ferrite core. I experiment with coils at the bottom. Usually the coils are shorted. What I've noticed is when I put a ferrite ring or coil, like a choke, inductive choke, it tends to pinch or push the plasma around. So I was experimenting with here. I did this glass actually in bismuth, molten bismuth, and then it basically melted all off except for this little part here that kind of unfortunate looks like something for junior high bathroom humor. But that's what you're seeing here. Here's another picture of it. You can see at the bottom I've melted all of the bismuth. But there was some really interesting effects that occurred from this experiment, but these are just some of the plasma. Each experiment has a plasma signature. So you'll notice it as I change the environments, it's changing the signature. And I'll just make small changes. And sometimes they have big effects. So I'll just
I keep telling people, change the environmental condition, it changes the energy.
That's it.
Hey, go back to one of the first ones you showed, Sean. I want to show you something.
I'm sorry. Say
Go
that
back
again?
to on the pictures. Go back like 4 of them.
Okay.
Keep going.
It's hard because of the lag.
Keep going. Couple more. Right there.
Oh,
Go forward one. Now, what do they call that? Parabola? Where you see
Parabola?
things and everything? Paradoia? Is that what? I can't say the word.
Pareidolia.
Paradonia. Look at look at in the center. It looks like Jesus on the cross.
Oh, I didn't see that.
Oh, yo, that looks like the Shroud of Turin for real. That's not bogus at all. No,
Wow.
Scroll up. Oh, that does look like Jesus, but scroll up.
Huh.
Scroll up. That's crazy. Look at what I'm looking at. Now zoom into the very top. Look at the hands crossed with the head.
I can't zoom the top better than this.
It literally looks like Jesus Christ with his arms crossed on the Shroud of Turin above what Nathan separately saw as the crucifixion. That's insane, Sean.
I'll have to play with this one. Wow, guys.
Well, we're going to send that screenshot around. Because
I'll definitely send this to you guys. Wow.
That's crazy how you see that kind of stuff in there. It shows up in plasma everywhere. A lot of religious stuff is in plasma. Every single one of the symbols I see in religion is in plasma.
With the halos and the
All
way
of
they
it.
draw. You can still see this cross. It's just interesting now that I can't unsee it.
no, you can't.
Well, that's a cool
In that
picture.
one screenshot, we need that. That's
We'll
Oh,
do.
dude, I told Sean, by the way, that he should take these and make them like full photos for people to hang on their wall. Dude, I'd be happy to have some of these on my wall, dude, as pictures of just pure plasma. They look
Oh,
fantastic.
cool.
Like this one here,
I
that's
think
gorgeous.
that could actually be my realm of
Yeah.
that, isn't it? Because I could print these things to look
That's
insanely 3D.
dude, that as a poster would be awesome, dude. I'd hang it up on my wall.
Yeah.
Yeah, I get that feeling that there's a strong artistic component to it, and it almost becomes me shopping for art shots because it's so pretty.
Yeah.
Um, yeah, Joe, let me know. I'll send you either these screenshots or I'll send you the 4K video cloud link to ensure you
Yeah,
guys.
definitely. Yeah, we'll get on that one because I mean, stuff to be done.
Yeah.
Oh, look at this.
Well, so this is
Dude, it is art,
Drive
Sean. By
through.
the way, that big carrot was your anode. But showing the other one, it was your anode coming down.
It was
However
my-
you connected it. Just like this one shows.
the oddness of this one is that you can't really see the tube here very clearly, but this shape here, this is a
The
shadow.
structure.
It's a
Oh
superimposed.
my God. Oh, sorry, Sean. I see the double layer in it. Do you see it?
Mhm.
Upper left of the same thing you're looking at. It shows it perfectly.
Over here.
Yes, double layer. The inside's dark. Okay,
I can see
perfectly the way you're supposed to see it. That's how you make a field bubble.
That's it. That is the perfect depiction
Yes.
of the unseen. You know, and Sean never fails at making the unseen come out and show itself somehow.
Yeah.
Appreciate that. Thank you. It's very encouraging. So this is a
It's
very
funny,
thin-
Sean. So I got to say this. There's a lady out there that just writes plasma books, right? Joe knows her name. I keep forgetting it, right?
yeah, I don't
Ripple?
remember her name either.
Kipple.
Oh yeah, I was gonna say Dana Kipple. Yeah.
Dana Kipple. You could literally take these pictures and put them in her book, and it'd be like out of this world of physical
Yeah.
plasma.
You know, I unbelievably respect and align, you know, with Dana and where she comes from. She's one of the only people that I could literally watch hours and hours and hours of and not disagree with a single thing she says, you know. But the one thing that I mean, you know, and maybe there's a chance that it'll get back to her somehow, but the one thing that was a bit frustrating is I knew the significance of the work we were doing and what she was saying and the connections we drew. But the difference is that, you know, she was going to like facilities and this and that where they're just messing around in all the wrong configurations a lot of times, you know, and they were seeing these things as anomalies or, you know, oh, okay, it can happen, but we don't understand the nature of it. And you know, I know what we're doing shows it each and every day.
Yeah.
It shows it each and every day with the same exact explanations, you know, and the same exact implications. So, but Sean, this stuff is absolutely beautiful. This thing could, like you said, this could hang that could hang on a wall and in anywhere, and nobody would think twice about it.
Get
Like,
an art
like,
exhibit for
you know,
Sean.
I'm sorry, say again?
We'll go into Chicago and make an art exhibit for Sean. We'll put it on all the walls in there for the day and let people comment on it. I think it'd be awesome, dude. They'd be tripped out.
It would
You
be
know,
if this thing was blown up big on a canvas and
Yeah.
done nice, it'd be unbelievable.
Wow, thank you guys. I'm gonna ask my wife. She likes to print things and hang them up, and so maybe she'll like a couple of these. So, but yeah, if you guys are interested, also you want to poke around these plasma videos. This was just a quartz tube that melted because it was so thin, and then the plasma would run inside, then it would jump out. And I thought, wow, let me get it when it's jumping out. And I ended up with these really pretty pictures. Like here's another example where it's half running in, half running out. It's actually running on the outside, but you can kind of see it almost looks like a guy kicking and dancing. Can you see this new one? You guys
I
see
mean,
the
that looks like something over the ocean to me, man. It's crazy.
Oh, it
Oh,
does.
yeah.
I
Like
wanted
lightning over the ocean.
yeah. If you see my arrow here, I kind of want to investigate because you know how we're always getting that fractal snow. This just seems crystalline or something. This doesn't. whenever I see this, it usually ends up being some kind of not crystal, but crystal-like or fractal-like structure.
Yeah, I see that. And it's definitely structuring the material where it's where it is.
And yeah, it's interacting with the plasma, but I don't think it's the plasma. That's what I was. This one came out really pretty. Again, I'm just snapping with the iPhone. I kind of see how beautiful these things are. This one's
look
pretty.
at that one.
That's literally an energetic projection. The one that was before this.
The one. So right now, the one we're on. Do you want me to go back one?
I mean, I was just making a comment as you were flipping through.
Oh, okay.
The one that was just before this was literally an energetic projection.
Look at that. Oh, I
That's-
missed this one.
That's dielectric brake, but it's leaking and way over capacitance. So it's able to actually structure what's no longer a current arc. It's a plasmatic arc fully, That's absolutely incredible.
Sean, we should make some shorts of these to show the different pictures to make sure we put at the bottom 100% real experimental plasma.
Yeah. And the thing about plasma, so one of the things I'm doing here kind of on the side is that I wanted to learn how to blow glass and then evacuate the air and add some noble gas and then make a high voltage circuit to kind of make it look pretty. But everywhere I went, it kind of looked the same. It was repetitive, or it was immensely expensive, but it was, again, repetitive. All of these plasma experiments are, I'd say, at least as beautiful, but there's no, you don't have to blow glass. You don't have to do anything. You set up your iPhone, and now granted, you need to know something about high voltage because this is dangerous. So, I mean, but other than that, the recipes there, it's not as easy as it looks to get started, but once you get started, it ends up, be almost like intuitive. So this is one I really liked. These vortexes, if you look at the top, they're everywhere now. I think I forget. Nathan, you had a really interesting explanation for these vortexes here. Do you see the one at the top here? Upper right corner.
I'm sorry. Give me a second.
No worries.
I'm looking.
You're in the
I'm looking.
comments.
You guys go ahead. I wanted to find something
Yeah, no sweat.
because you were talking about the energy and that bulb I sent you. There was the coolest bulb in the world, guys. It has absolutely no filament in it, just gas. Here we go. I'm going to change this real quick. Just give me one second. I'll put you back up, Sean.
Yeah.
Take a look at this thing. So this right here just has gas in it, and it has the bulb in it. That's it. It's Tesla's design, and what it's designed to do is take like a Tesla style energy from a Tesla coil, or something from the hairpin circuit, and excite the gas inside of it, and it lights up. Absolutely no wires in it whatsoever. So one of these was $160 on Etsy. Okay.
Oh, wow.
And I wanted to get one because then I was telling Joe earlier this, I can take a vine from a plant, connect it to the water source, right? That I put my ions into from my hairpin circuit, and I can light this bulb. So when you see ancient Egypt and you see the bulbs on the wall that they described in the hieroglyphs, it's the exact same process. I'm taking a vine, not a wire, a vine, and turning it on. Basically taking a house plant and turning this bulb on, which confirms the theory that they were working with ions in their understanding of how the world works, where we think of it in the wrong way altogether.
Yeah, we do. So here's the deal with plants just in general. If you never really noticed, you ever kind of notice how they're the same at the top and the bottom? You know, that's because they work off of their relationship of two sides of energy. You know, they're dependent on um, the ground energy, and they're dependent on the solar energy from the atmosphere.
Hmm.
You know, and just the energy from the atmosphere in general. And what you end up noticing is that if you increase the altitude that you go to beyond a certain threshold, there's different heights that the plants tend to grow. And the higher you go, the shorter they tend to be. Why? Well, because they're further up already, right? Then in the scope of the atmospheric energy. So they're able to get the ground energy at a good proportion and not have to go as high to get the same energy needs of the specific plant at a higher altitude.
Well, that's
Um,
because their pyramids pull in ion energy.
and the branches and the roots act as literal an antenna, but
Yeah.
they act as an antenna, you know, for the intermedium of both. And that's the critical aspect to understand. That's what I think people tend to miss, right? So because an antenna both can transmit and receive, you know, an antenna tuned specifically to ground energy, won't work unless if that ground energy is in perfect coherence with the atmospheric energy, which, as we know, is variable, and so is the earth energy. So what it needs is a broadband fractal antenna, okay, that basically it can bridge the gap between the two for an energy exchange between not only the plant is the intermedium. The plant is acting as an energy exchange constantly between the atmosphere and the ground.
Yeah.
A receiver transmitter.
Anyway, I wanted to point that out. We'll go back to your stuff, Sean. I wanted to show what that was about because that's going to come up very big here real soon.
Yeah.
Because I'm going to put it through the vines and start it up, and then start going on all these ancient Egypt channels and showing them how the energy works, how
Cool.
it actually works.
Good
I
stuff.
mean, you might be able to just do that with the standard gas tube for what it's worth, but the fancy glass tube looks nice.
Well, if you take out all the explanations somebody gives, if you remove all the filaments, it pretty much says, you know what? We're not working on the level you're working on, buddy.
Yep.
So Vortex cracking me up in the chat. He calls this glowworm farts. And
Nice.
or a rectenna. He says
can
a
see it.
rectenna.
Oh,
So he's very witty. I love it. So let's see.
well, you know what? You know what's ironic? And I don't mean to sour the conversation a little bit, but when you light your farts in there, there's green gas that comes out, and we see the green gas that comes in all these experiments. I just thought it was funny. You know what I mean? You may have a conversion going on you don't know about.
Definitely.
A little methane in there that you didn't realize was in it.
That's right. I had chili beans the night before the experiment. and-
Dude, I would pay somebody to go by one of these experiments and blast it out. You know what I mean? Everything would be on fire inside of them.
There's a story of my uncle lighting his farts and he got burned. So it's a family tale. So this was that first quartz tube that I thought was a big fail, ended up being really introducing a whole next level of plasma
Oh,
experiments.
dude, that's rad.
Yeah.
There's so much going on.
It's really cool. It's riding itself, it's like Metallica riding lightning. It is riding the lightning, and the lightning is itself.
Oh yeah.
It's funny, the bent paper clip here at the bottom is sticking out wrong, so it just hit the paper clip here on the lower left.
See, that blue only shows up when you do a voltage multiplier.
Oh, really?
Yeah, so when you take an AC flyback and you do a voltage multiplier on it, you get that color.
Hmm.
You must have hit some extra energy in there.
No, I've seen that. You're right. I didn't notice that. This is where you were saying it almost has like a religious art.
Oh,
These
zoom
rabbits-
back out. Is
Say
it this one or the next one? I think it's the next one, Sean. If it's in the same, no,
no, it's not the
that's
same.
beautiful. But
There'll be a video coming though.
the first one you showed when we originally turned it on, that's the one
Yeah.
that we wanted to see.
I mean,
Yeah.
that glow, it tends to like really start to reflect creation at that point. Like that's sort of kind of how I imagine it.
Yeah, no, you're right. As soon as Nathan said that, if you're familiar with Orthodox icons or Catholic art in the Middle Ages, it has these kind of auras and these kind of, when God's creating something or they're angels, it all sort of fits this kind of scheme, color
does.
scheme, and all kinds of like, again, it's like almost like medieval art if we didn't know it was plasma art. So I'll use an inductive choke and I'll short it, because if I don't short it, really nothing happens. But if I short it, it tends to then push the plasma up in spots and cause pinches. So interesting. Again, just here for the plasma art. This one's
Yeah, you might have been there for the plasma art, but there was a huge entity at the bottom of that bottom one, so I don't know. There's
do you want me to go back, or
if you want to, yeah,
this one?
yeah. Look at the green and blue surrounded by the purple.
Yeah.
I didn't see that until now. Wow. It's like the lens flares inside the sphere with the RAV.
Yeah, except for the fact that it's in the shape of an eyeball and it has the same exact proportions and curvature with the pupil. But
It does look like
we'll
it.
go with that.
And,
Emitters and receivers.
right. So this is what I mean. Even though you're getting this almost chaotic looking plasma, when it forms a RAV, here it's forming it outside. You'll see the left hand corner. You'll see kind of a fuzzy lens flare. I follow those lens flares because they always tell you where the RAV's at. Maybe this is a better one. You can see lens flare over on the left, and then it's reflecting the RAV here that's hitting the aluminum heatsink. And there's also too, if I were to like cut out certain plasma, like this photos, it literally looks like nebulas and black holes and gas clouds and neutron stars. I mean, all that stuff is, or not neutron stars, but nebulas. This can pass for a nebula, I bet.
You do realize that we're talking about plasma is the exact same thing we're talking about in space, right?
Right.
It literally is the same thing. So when you see a nebula, it literally is the same.
And we're all talking about, all this is a spark. There's no manipulation, there's nothing, no electronics. It's just a spark. It's just DC, and then it gets all its frequencies and all of its cool stuff as it travels, and it's manipulated by the different environments.
Yeah, I look at that one. I think what some people miss in all of this is when you're looking at plasma, it really amounts to how much pressure you're putting onto it, which brings it into the energy state that you want to see. Okay. So when you see it in space out there between solar systems, you're actually seeing an environment that pressurized a little bit, and you're getting some kind of nebula that forms or gas to bundle together, something like that, right? It's its own environment that's created around it. I don't think people understand that. And we get such a heavy lensing between solar systems, you wouldn't be able to understand the difference. Hey, Sean, go back to that first photo that you brought up when we were sitting backstage.
Yeah, I had to stop the presentation here to find it. So yeah, it'd be good to end on this. I wish I had the video for this because the video of this is insane. Probably the craziest video, and yet, of course, I don't have it. So maybe next time, let's see, I'm figuring this out. I'll share this with you.
Well, one thing, the heat sink that you're using, son, if you look at just the top of it, it looks like the moon. It's all gray looking. You know what I mean?
Yeah, it does.
It's
Totally.
kind of cool when you look at it because, to be honest with you, if you think about it this way, if a RAV started in the center of the moon, which it probably did, then the outside of it would reflect that. It would look gray. It would look like what you're dealing with the moon, right? It would have light that comes off of it because ultimately it's in a decay rate because it is radioactive. And that's what you're going to get in the sky based on that. So, dude, the moon builds up perfectly to give you an example of how plasma physics works in our universe and how it was a satellite originally to our planet. It was never a capture, was never hitting the planet. It was never, accumulation of garbage inside of our solar system. It originally built out with it in plasma physics that you show is exactly what happened.
I think that's a more plausible theory than what they have out there. I'll just say that.
Because you could see it. You could watch it do it right in front of you.
Every time they put a telescope in the sky, the Hubble, and then the upgrade of Hubble, and now the Webb telescope. I've been watching the Webb telescope being built since 1995 or something, and they just built it like 2 years ago. Most of the astronomers' predictions are wrong. It's so crazy. I mean, they literally say we're going to see this, 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 and this, and then we're going to have to update all our models. There's nothing wrong with that. Science works that way, but they seem to just stay on this one-track mind, and they can't deviate from it. I think it's more of a worldview is why they can't deviate.
Wait until they realize that everything is just folded up into like basically an envelope. It's like a letter folded into a small piece of paper and stuck in an envelope, and we're just at any given point inside of that, and trying to be like, oh, this is what it is. It just simply doesn't work. The relativity says that the measure is only as good as what it's relative to, right? So when you are taking your measurements from so close to proximity from initial point of observation, how good are your measurements? You're still relative to all the same stuff. At that point. So
here's the one that melt your brain even more. We only know the two-way speed of light average. We do not know the one-way speed of light. We can't calculate the one-way speed of light, and you can look it up. And so you can pick now the speed of light one way, as long as you then add what is it? If you add it to the speed of light, then take the average. So I'll use an example. If you were to say a sun that is 1 light year away, you could say that you could travel the speed of light for that light to hit us and take 1 year. Or you can say the light hits us instantaneous, and then the light travels back at the speed of light.
Well, we've described before this idea that light doesn't have a speed as it exactly pertains. I'm sure it has a speed, but that native speed is not relative to any sort of observation that could be measured. And that the speed of light, by definition, is in Planck's scale as a parameter, and therefore is merely a dimensional threshold. And I say dimensional threshold not because that's the terms that I like to use, even though it is, but because that is what the Planck scale is deterministic of. The Planck scale is directly related to dimensional thresholds. And the speed of light is the dimensional threshold on the high scale of things. You see? So everybody likes to talk about what happens when something gets smaller, right? Oh, well, what happens if if it gets indefinitely small, smaller than an atom, smaller than a subatomic particle, smaller than, and then bang, all of a sudden they phase in and out of existence, right? Well, that's not ironic. It's because of the same exact thing, the frequency scale. The frequency scale is what's deterministic of the Planck scale, which is also deterministic of the measure of light. So when you're looking at the measure of light speed, it's not the speed of light, because we know that light is not manifest while it's transient. Okay, if it's not being reflected or refracted or in interaction with matter in any sort of way, it's simply in a transient state. And in that transient native state that it's in, it is not abiding by the same speed that it's being dimensionally restricted to. So every single measurement that they want to sit there and say as part of cosmology and stuff is absolutely inaccurate as far as the grand reality is concerned. It's only relative to this dimension that these measures mean anything, which means something, because this is where we are. So you can't lose track of that, because that's the thing that I think even I lose track of sometimes.
Okay, so just understand this. You're dealing with zoning. So if you go to the outside of the solar system and then go back to the inside of the solar system, each thing builds out in layers, spheres. So when you do that, you change the viscosity, you change the amount of energy to each one of them as you travel through it. So there's no way that the speed next to the sun matches the speed that's on the outside of the solar system. Okay? They're two different speeds because there's different frequencies that go on in between them. So it's not the same speed. It slows down as it goes. That's why you'll have a spaceship that shoots out and eventually it'll slow down. Okay? Or eventually it'll speed up if it hits the right set of frequencies and amplifies where it does. Okay? That's why they can't explain when things get faster in the solar systems and when they don't. They don't understand this on a fundamental level of energy that goes out there, right? The speed of light is dictated by the sun. Okay? And it's only because they see things as electrons as they say speed of light. Because they don't know that there's ions in the center. So if that's all you see is the electrons, then you're going to talk about the light. But that's not what energy is out in the cosmos and stuff. Energy is based on the energy before the light. So they're not seeing it correctly. They're basing it on an electron effect, which is the magnetodielectric that goes around an ion. That's their light that they're talking about. That's the speed of light. They're not understanding the true speed, which is the inside. That's why you can make a wormhole that goes from this solar system to another one, because you're simply aligning the inside of it, of the ion, which is a vortex in nature, to plow right through it and pull up like a wormhole through the next one, right? That's why all that stuff is available to you. But they can't get past the fact that they see electrons everywhere. And because of that, they ruin the entire experiment. There's a whole side of physics missing from what physicists see. And their calculations are all based on the hot energy of the electron, but they're not seeing the ion on the inside. They miss half of the world that's going on because they don't understand energy properly.
No, they don't.
Do you think
Takeaway.
Do you think the stuff that we're going through here maybe could help explain visually explain some of what you're saying?
So
Okay.
it's a sub process. The stuff that you're showing are sub processes of the greater process of stability. So when the RAV is not achieved, and I have to be very specific about that, because when the RAV is achieved, okay, things change. But in the arc patterning and stuff like that you're seeing, and it directly correlates with what we were going to talk about today, and but hopefully we'll touch on it a little bit. But the idea is that there's a set of processes, vectoring processes that go on. Now, as you know, whenever you have control of the energy vector, Okay, and it's transitioned through the electromagnetic modes. Okay, what ends up building is one side of a system. Okay, now if you have that system return in an exchange, all right, what you end up with is the whole system. When the RAV is not formed, what you're seeing is the building blocks, okay, the prerequisites, okay, for that exchange to take place. All right. So when you start to see, counter flow energy traveling up a plasmatic tendril and blowing off, charged particles, and you
Yeah.
start to see the greater dimensional geometries start to form in the environment. It's because you're conditioning the environment, and the whole thing is that you need the environmental conditions as a prerequisite, okay, to the exchange stabilizing, because the whole nature of the exchange is actually simple, and it's what physics likes to say is impossible, but it kind of is when you use their own theories and their own practices, their accepted practices. The idea here is that you're breaking down matter, and then through a matter of energy exchange and attraction and repulsion in that energy exchange, you're actually separating your bits and pieces. Okay, so you're taking your differentials and you're putting one side of differentials on one side of the equation. You're putting the other set of differentials on the other side of the equation, and then you're letting them nicely recombine. Okay, and that and exchange through that exchange, and that's the nature of it. That's Maxwell's demon. That's the missing link. That's the break of entropy. That's creating a closed loop system, okay, through coupling. Okay, and that's the key to it all, is that people think that you want one wire in, and in your wire out is all of a sudden going to come all sorts of energy, all sorts of this, all sorts of that. It's like, and then that you could hook one end to the other, and then it flows around. And this is not the way. You need the source to be an open source as far as what's powering it, and then you need a closed loop system that's as a result of self-organized field differentials and coupling, which is exactly what RAV does. So what you're seeing is the buildup to that. And when you're pushing the energy density level so high, Sean, and then you're using different materials to do it, and you're always using a dielectric that's ultimately kind of, it's manipulating it. It's either containing it, but then it shoves it out, and then it does this. It allows for that structuring to occur through inductive capacitance, and until the dielectric breaks, and then you start to see what you see, and the dielectric always has to break in order for the RAV to form. Even if it's inside of the dielectric, it still has to break that barrier, because the field has to be able to push out beyond its confinement. So
Okay. I want to say this real quick.
Current. You need a minute current for these minimally.
I want to say this so people understand this. They see ancient aliens and stuff, and they think that there's doorways and mountains. I just need to explain this so people understand. That's not the doorway. It's a vortex. So I don't understand this. So if you have a sheath layer like this, okay, on the outside of our planet, right? We have our boundary layer right here. There's swirls that go up a vortex to go out. Then you get to the water layer. There's vortexes that go like this. We see them in the planet all the time. We don't understand them. The Bermuda Triangle and the Dragon's Triangle is a vortex. Okay? That's why ships get messed up all the time. It's a compression of ions in a field. Okay? So when you go there, you're going to get radiation. Your ships, none of the things on your ship are going to work right. Your compass, all that's gone bananas. It will not work right at all. This is what this stuff does. It like takes over your computer, everything. Completely different energy style. Okay? The vortex to get from one side to the other is the energy exchange that goes on between them. The energy from the ions that comes in, it goes through the barrier, swirls, goes through the barrier to the other side. As it gets to this side of the barrier, okay, you're in a different time field. So if you think of the planet as layers, and we go down, we get into the time dilation where time slows the closer you get to the inner core, which means there's an inner layer inside of the planet. There's a layer we stand on, there's a layer on the inside of that, and there are layers on the inside of that. And they found giant caverns where there's huge layers in there. Will they propagate light? Yes, because that's exactly what the sheath layer does. As soon as the ions get to a certain point, they start to conduct light when they hit impedance. So there'll be light in there at all times. So Journey to the Center of the Earth, if you're into that kind of thing, that's exactly what you're looking for. Those are your portals. They're not holes in the wall. They're not things in the side of a mountain. They're literally the vortex that you see going on. If you ever looked at like by Miami and stuff over there, there's vortexes everywhere in there. It's littered with them. And then when you get to the Bermuda Triangle, it's a huge one. That's why people have all kinds of different problems when they get over there. There's vortexes that create sideways that goes on in them. They have a lot of people talking about they were flying, went to a vortex, they ended up on the other side, and it was like difference of 5 hours that they saved in their flight time, and then their fuel, echoed the same thing.
That has to do with the equator, okay? And the idea is, if you notice, nothing messed up ever happens by the equator. Like, not by the equator, like on the equator. All right, like, you don't get extreme weather on the equator. Like, it's hot, but that's what you get. There's a situation that exists where the state of diffusion, it's about to collapse. It's about to turn around. It's about to go from state of diffusion to state of compression once you cross that line. And what that means for everything leading up to it in the tropics, anything in those zones, is that all the higher energy density state is actually pressing up against and working up against this more calm circumstance, which immediately starts to spin it, because that's just simply what, that's what happens when things hit resistance. They start to curl up into themselves, and you end up with all sorts of vortex type things. And this is why all the hurricanes are born in the same exact region. They're all
cold and hot, right?
Hey guys,
the origins. It's the separation of differentials hitting into that state of diffusion. It's like, well, there's a certain cusp that it hits where it becomes a resistance wall, where the current is actually hitting something still, and like anything that's moving, hitting something still, it gives. Especially when the mass is greater, because as you move toward the equatorial plane, the diameter and therefore the mass and areas of the maximum circumference, is greater than that which is pressing against it. You see? So that's how it works.
Okay, let's pull this up. This is
I got about 5 more minutes, guys, if that's cool with you. But yeah, definitely want to share this last piece.
Share that, and we got what else. So don't worry, Sean. We appreciate your time, brother.
I appreciate your analysis, and you guys let me on the channel. Nathan, you wanted to revisit this one, and then I have the video of this if you want to actually see the video.
Oh yeah. First of all,
I mean, that's literally epic, man. This is the crown jewel.
Yeah, let's look at the bottom real quick, just on the top of the heat sink. This is what I say. It looks like the moon.
Yeah.
So you look at it, it's all gray, it's all dusty. You got hills and valleys on it. It would be perfect if you took it as a screenshot for a Hollywood movie for a moon, right? And then the top looks like religious. So you always see candles and light and angels, things like that, and you see the field and the glow from the outside of it, which means it should give you a hint. Angels are light. And it shows in this that what you're actually looking at. So we say we're beings of light all the time. I don't think people truly understand it, but if you just understand the implications of it, you can see this. You're getting that field around you. We actually have a field like this around our body at all times, but we're not exerting enough heat energy to show it the same way that you would show this. We'd have to have an exorbitant amount of heat to do it, but we still have it there. So you have to find a way to see cold temperatures in light to see it. And we haven't developed the technology because I don't even think they know they're there. So this has a double RAV on the top. You can see clearly both.
Yeah.
What I worry about is it looks like there's a third at the bottom, and then before that, at the very top, you see where the energy goes top to bottom. Looks like there's one there, so it could possibly be 4 or just a breakout to get to the third one.
Yeah.
But the cool part of this is the light. So you see at the very bottom, you got the light. Looks like a half flying saucer it sits in, and then right above that, if you look, you'll see it again.
Yeah,
That was
and
fun.
if you look at what the light's doing, this once again is what we're talking about. This is field coupling. Okay. There's no reason, okay, for refraction past that far past and symmetrical to the two main points of emission, except for the fact that it's being guided and bent by the fields in which it is a part of.
Mhm.
And because those work in a coupling, right, and you could see it, you could see all the lines and how they're broken out. And even the lines off the bottom one, they match that of the first. It's simply field coupling. That occurs in these things, both with the environment, but in this case, amongst themselves as well. In the way that we always try and describe, but because there's generally an absence of a second, event, right? You really can't see the coupling, but this gives it to you. And I mean, the fact that there's two that's a testament.
Yeah, thank you. The standout thing was, and we'll see it in the video, are these light rings. They emanate. That's just weird because I've never seen. You'll see it almost looks like CGI. Maybe let me see if I can get the video. So if you look at the light here, it switches. So right now it's concave in one direction, then it's concave in another. So there's a lot going on here, right? I'll just let it play first. These are very mean RAVs. That glass is heating red hot. And because it's quartz, it's not cracking, but that's almost molten glass.
Are you playing the video, Sean? I'm not seeing it.
You're not seeing it? It's been playing here for a minute.
Oh, no.
Oh,
Just
I'm
the-
sorry.
We're seeing the picture.
So I'm on the video. Let me see if I can switch it. Okay. Oh, you know what I think is going on? For some reason the photo keeps showing up as last, and the way you're
Send it to me on Facebook. I'll pull it up.
Okay, I'll send it right now. Yeah, I think this will be your favorite video, guys. I don't want to get your hopes up, but I really think this is going to be the climax here. Let me find you, Nathan. Let's see, come on. We are getting ready to watch the last RAV video. All right, let me see if I can give it to you. No, it won't let me. It's too big. Let me just get these to sort differently in the folder, and I think it'll work. Let me try this.
Okay.
Yeah, or close it out and open it back up.
Yeah, I've been doing all of the little tricks here. Yeah, if you give me a sec, I'll get it working.
Oh yeah. Go
Be
do
right
what you gotta
back.
do.
Sorry.
All right. So while he's working that out, I want to show something about 369
Yeah, go for it.
real quick.
Here, I'll put you up on the screen.
Yeah, well, all right. If you map out Rodin like in an actual graph, okay? What I want you to see is something very interesting. All right, because and maybe this won't make 100% sense now, but if we get into it later, it probably will make a lot more sense. But what the graph tends to indicate is that there's a retrocausal reaction that occurs as a result of 369 when you graph it out two-dimensionally. Now, the anomaly disappears when you um, bring it up in dimensionality. Okay, but what you end up realizing quickly is that when you break it down to its most fundamental vectoring scheme, to relate the proportions, you have a situation where both need to fire in order for the event to occur, but it occurs at a when the two cross at the switches, and that initiates the sequence, and before one or the other fires, before the three fires, at the 4.75 mark right there, okay, it hits the 9 right there, right? So there's some when you break it down geometrically and into a linear dimension, it actually implies retrocausality, which is very, very interesting. But I just wanted to share that one point because I thought that was fascinating.
Retro causality. That just sounds crazy. I mean, that sounds awesome. I think I got it working. If you guys got a second and before I disintegrate.
Sorry. Yeah, put it up, Sean.
Okay, I'm just looking for it. You got it?
Oh, here we go. Yeah.
Let me know when it fills the screen and the photo should be filling the screen first.
Yeah. Got that.
Everybody sees it? Okay. Now I should go to the video.
Oh,
You guys
this is
see
the video?
You can see it?
Oh yeah, and there are 3 rafts. Yeah.
Isn't it nuts though? The glass is red hot. Nothing, no RAV does that. Now, granted, these RAVs aren't completely coherent, but the lens flare definitely gives you clues that they are RAVs.
Yeah, but this is hot plasma.
It is a RAV, and this video incredible. Okay, this is exactly the point that I was making earlier, Sean,
Okay.
about the dielectric breakdown. Okay, because if you notice where they're hitting, it's where the dielectric is breaking, and where it's actually penetrating and reacting with the hot surface. And the heat is what's causing that dielectric break in this case because of the resistance. Once you put enough resistance on it, it causes that K value crash.
Crazy. Yeah, no, I can see it totally. And it just the early part where this action here is like, it's like it's a lot. I guess just for me it was that light band. I don't see these light bands anywhere at all ever in any experiments. Now, granted, that's some crazy plasma action going on. And the way it's reversed, and then it'll flip. See if I can find the flipped one. This might be not be the video. Yeah, well, okay, here we go. Yeah, so they kind of meet here in the middle to the right of the column. Do you see the 2 light bands on the background? And then you see it now, it's only 1 on the right. Are you seeing these or?
Sean, we're seeing it. Yeah.
2 again on the right and then 1 on the right.
Yeah.
And they'll either do this or they'll start in the middle and they'll just emanate, and then they'll change directions and then they'll pinch or switch and emanate. It's so interesting because there we go. So now you see them around it on each side. Maybe it's nothing. Maybe a trick of the eyes. I don't know.
No, there's something there because I saw it. The lines are shifting. The two on the outside look like they're going in. They were opposite of that earlier. Right there's opposite. See
Yeah.
it?
Yeah. And you're not getting the other shaped one here, but so here you go. You got, so it's almost like instead of a double slit experiment, it's like a single slit experiment. I don't know. I'm spitballing.
Whatever it is, it's a remarkable experiment, man.
Thank you. Appreciate it. Look at the lens flare, Nathan, right here. Look at that green.
That's a really pretty color.
Yeah. That's another thing that, they say lens flare is just sort of this repeating useless artifact, but no, we're seeing we know that there's a spinning coherent plasmoid, but if I could use that word, but the colors of the lens flare are very different and the way it looks.
Yeah, I wish people can understand this. They say it's like a camera effect, right?
Yeah.
Here's the problem is it tracks when you spin the whole thing. Therefore, it's not
Hold on,
camera
go back.
effect, it's a lensing effect.
Important. Nathan, important. Go back in the two frame. All right, what you were just saying, as you were saying it, was automatically debunked by the fact that there were two lens flares, one atop the other, and that can't happen when you're dealing with a single convexity.
Yep.
You're right.
And you can see it.
Whoa.
It's right there, right above the other one.
Oh, no way.
So if you're dealing with a single convexity, you can't have 2 points of convergence.
Uh-oh, there goes the camera people.
That's
They're going to be
crazy.
on now.
That's totally crazy. So I'm fading, like this video will fade here soon. I
Oh,
appreciate
wow.
you
Hold
having
on.
me on short notice.
That thing in speed, we're going to have to look at it again, Sean, because there's something else going on there.
Yeah. We'll share this and amongst ourselves, and we'll bring it back next week with a real good breakdown.
Awesome. Yeah. All right, guys. Nathan, thanks for letting me on. Guys, thanks for listening in the chat. I know it was last minute. It was kind of haphazard, but I think Nathan and Joe provided some really awesome details around these experiments. Nathan, thanks for letting me have the floor, and good seeing you, Joe.
Right on. Sean, we love you, brother, and it's always great having you, and hopefully it won't be so long until the next time.
Thank you so much. Love you guys. Love you all. Bye.
Right on. Thank you, Sean.
Just amazing, man. Absolutely phenomenal.
Oh, it is, because we always see something different than what he saw, right?
It's just a whole, we look at things through much different lenses, and that's what it takes, but Sean has this intuitive way about the way that he proceeds with these things, things that seem they're outside of the box. He pushes the envelope. It's like if you would have told me, oh, well, I'm going to try this as a variation, I'd be like, all right. I mean, yeah, okay, I don't see the point. But the point isn't always the result. The point is sometimes just exposing the parts that you haven't seen before. Like, that those parts are there.
Yeah.
But you haven't seen them. And, like time and time again, he finds these ways to just, take the theory and then be like, and hear it, and here's where it's doing that part. That's hard, because when these things fall into these modes where they're actually going to become stable and everything, they snap into those modes like that. Your camera can't even catch how quickly it falls into those arrangements. So to actually stabilize each specific arrangement, that's incredible. you know?
Yeah. Well, I agree with yeah, they've been stuck since 1800s. As soon as they came up with how a magnet works, they ruined physics. Because then they took it as how the world works when we manufacture magnets. Total misunderstanding.
Hey, just to break it up a little bit, because we've been going for a little bit today. We didn't touch on what we were gonna yet. I was thinking, break it up a little bit. You want to throw that song on that I did? So
Oh yeah.
yeah,
One
so
second.
check it out, everybody. This song, I wanted to share it, but it's not done. It's probably about 60% done. But the lyrics were where I wanted it to be, and I kind of got a little head bob going to it a time or two. I really like the song, so I was kind of excited to share it. So I'll share it as a preview in its undone form. And when it's all done, we'll bring it back up. I'll post it on my channel and let everybody know. But I have the better part of an album going now, so I'm pretty excited about that because I'm going to put together music videos with it and everything. And I think it's good experience for everybody. But this one's a little less physics heavy, this song, than some of the other ones.
I can't pull it up, Joe.
No?
No.
Oh, that's a bummer.
It'll play the sound, but it's going to give me the background of all Facebook.
All right. Well, I mean, if you don't care, I don't care.
Hold on. I don't want to share private conversations either. So,
well, I could send you a link instead.
Send me a link.
All right, I'll be right back. I'll send you a link.
Sorry about that.
Yeah, no, it's no worries.
Yeah, we'll get that song up and going. We'll take a listen to it, man. Yeah, crazy how things actually look instead of how we think they look. I always found that fascinating. I go back and look at old experiments to see what people did and see if it actually matches what physics says it is. And most of the time it doesn't. There's a perception problem. Huh. Oh, right on, brother. Right on. Hopefully everything works well for you, man. Looking forward to hearing some results.
All right. So this is in an unedited Sonos stage right now. I haven't brought it into manual editing yet. So, that's where it's at. But I was very happy with what I was able to put together with it.
Okay. Good job.
I've been searching for a place. I've been chasing something, somewhere that calls me, something that completes me, someone that becomes me, but I don't know who, don't know what, don't know where. Guess I'll feel it when I get there. I walked into the wilderness hoping to get lost. I found a voice so familiar, just had to listen. Whispered to me and knew my name, knew I was coming, knew why I came. It wore my mask, echoed my reasons, finished every sentence before I could speak it. Offered me kingdoms, told me to come. Seems the promise only existed inside my own permission. I let it talk. I hear my own words in my own voice, but I'm not speaking. What the fuck is going on? My body shaking without rhyme or reason. Change the tone spoken by its lips. Are these my own damn thoughts? The darkness begins to lift the devil. Its face familiar, I'd seen it before. And when it reached for my hands, I looked it in the eyes and kissed kissed it like Judas. There is no love in his dark-eyed stare. That's when I knew there was no deal. Kissed it between the horns from absolute lack of fear. It blinked first. Every locked door was framed from the inside. Every prison kept my fingerprints on the key. The shadow never wanted worship. It wanted unconsciousness. It fed on everything I refused to name. Every lie I called survival. Every wound I called identity. Every chain I polished till it looked like purpose. There is no emptiness and silence. Strip away the noise long enough, and something older than language begins arranging the room. The kingdom isn't waiting beyond the horizon. It presses against the inside of the skull. Every honest thought opens another chamber. Every false self dies without a funeral. I stopped asking for another world. I started seeing through this one. I started seeing through this one. The teacher never sold escape. He taught alignment, walked straight enough, and heaven quits feeling like a destination. The cross was never only wood. It's the place where the flesh and the eternal refuse to look away from each other. The path is narrow because excuses are wide. Truth weighs nothing. That's why so few can carry it. The kingdom isn't waiting beyond the horizon. It presses against the inside of the skull. Every honest thought opens another chamber. Every false self dies without a funeral. I stopped asking for another world. I started seeing through this one. I started seeing through this one. Close the eyes, slow the breath. Let the body forget its argument with time. The mind stops drawing border. Something deeper takes the compass. Not asleep, not dreaming, just awake in a room. Now is always there. The kingdom isn't waiting beyond the horizon. It presses against the inside of the skull. Every honest thought opens another chamber. Every false self dies without a funeral. Stop asking for another world. I started seeing through this one. I started seeing through this one. So if the devil comes looking, tell him I already know his voice. He learned it from mine. I've already seen his face. Step back from within. There is no disguise to blind me. I know where it is heading. When Christ asked why I followed, when his footprints have long since faded, tell him because he never promised comfort, only the courage to become undivided. The kingdom isn't waiting beyond the horizon. It presses against the inside of the skull. Every honest thought opens another chamber. Every false self dies without a funeral. I stopped asking for another world. I started seeing through this one. I started seeing through this one. When Christ asked why I follow, when his footprints have long since faded, I told him because he never promised comfort, only the courage to become undivided.
Dude, that was cool, Joe.
Thank you, man. I appreciate that. Yeah, I was proud of that one. It was a lot of words. I'm good at a lot of words. Everybody knows that.
Oh, I like the theme behind it and the song too. It's good.
Thank you. I appreciate that. Yeah, I thought it was a bit of a journey, you know?
Yeah. People in the chat like it too.
Right on. That's what it's all about. And everybody got to remember, it's all the same. I say it all the time. It's all the same. I also found something very interesting. And I'm still, you know what? I wanted to do this today, but you know what? Now that I'm kind of geared up in it, I'm like realizing, you know what? I might even be jumping the gun. Might be a little premature. I'll share a little bit of what the work that I've done on vortex math.
Okay.
And some of the realizations that I've made since then and where I'm sort of taking it. So I kind of stumbled upon this thing, right? Where I realized that Arabic numerals, like,
Okay.
numbers, as we call them, right? Why? Right? And then when I looked at them and I looked at them in arrangement, and then I know what the arrangement is, I was like, wait a second. It shows the thing. When you do the arrangement, it shows the thing.
What thing? I'm kind of confused.
Well, I sent you a couple of pictures.
Oh yeah, you want to see those?
You pull up that purple picture real quick. I think it was like a purple ink picture. And I'm still working on this, by the way. It's not 100% correct yet, but I could see it in my mind and it's just not making it there. So I know it works. But this is like, call it 80. No, that's regular. We'll get there too. But and this is super, super esoteric stuff. The purple one.
This one?
Okay, yeah, perfect. I know, probably looks the least appealing out of all of them, right?
Looks like a guy riding a bike.
It does, and I said the same thing, but here's what's cool. If you arrange the one, okay, and then you realize that the little tail piece of the one, okay, is your point of, where your energy is coming from, okay? And then you're going to run that energy through something, and then it's going to leave that, okay, and become an arc. And your arc starts at the right side of the bottom cross, right? And what ends up happening is it meets resistance. Well, what did we just talk about? When the current meets resistance, what does it do? It compresses, it bends. Well, I mean, when it compresses and bends, and then it bends back toward itself, it ends up being repelled, right? Well, I mean, that's a 2. And all you had to do was turn it, right? But what ends up happening is things start to mirror. And I realized that quickly. And as it turns back into a current state, okay, it ends up, crossing back over because of the magnetic component, okay, that is, formed by the 2. And the 4 actually connects to then an 8, but it's inside of the 8. And that 8 is actually the magnetic field that was what pulled it back in the first place. Because again, retrocausality is like a real thing in this. Like, it's just a very strange thing. Happens at the same exact spot that the retrocausality occurs on the chart. But it pulls back, okay, by the magnetic field, and then it has a the center line. It then goes inversely and exiting, but then gets pulled back into the magnetic field again until it's able to leave. And at that point, it's able to reconnect with the original end of the circuit in the first place. And what you quickly realize is this is exactly the vectoring that we've been talking about. It's just in a very discombobulated way. And I'm probably not explaining it as well as because again, I haven't fully digested this yet. But there's more to this, than sort of meets the eye, because there's sub spirals that end up occurring with the 3 and the 6 and how they pen in, and I just didn't have time to get that together. But so there's something to numerals, and there's something else with numerals too, is like the points in which to draw them. So like, for instance, most of the numerals have like 5 points to draw them. Like if you look at in a 2, for instance, you have the starting point, but then you have the apex of the bend as another point, because then it starts to bend the other way, and where it hits there and then it terminates at the end, it turns out to be like 5 points. It turns out it is like very interesting. Most of them have 5 points, but except for the ones that are like 7 has 3 points, and there's a correlation there. And 8 has no points, right? Realistically, I mean, you could consider the bends a point, but realistically, it's a continuation of a single line. And that starts to make sense because that's where it intersects in the center is where your 0 point lies. So it becomes very interesting. There's probably more to it than what I'm just describing right now. But seeing as we're 2 hours in at the end of my work week, I feel a little overwhelmed in having to delve into my mind that much at the moment. But there's like this whole entire notion of the 4.75. And I started breaking all this stuff down, and I'd said that I had in the past, never really described it. But if you want to go to the vortex math thing, like the Tesla 369, whatever, they call it, that shit. Okay, perfect. So I was starting to break this down a little bit, and what you start to realize is that you have different attributes to the different points that are defined by the different points in this, in terms of what they're doing, and then the numeric relationship. Okay, and that's very, very important understanding this whole thing. So what I found is that there's an ascending, an ascending expansion, okay, that occurs at 1, 2, 4, and 5, and a descending or contracting sequence that occurs at 8 and 7. Okay, then you have a right-handed bias that occurs at 1 to 2, 7 to 5, and 5 to 1, and a left-handed bias that occurs at 2 to 4, 4 to 8, and 8 to 7. Then you have a clockwise rotational bias at 1 to 2. 1 to 2 to 4 to 4.75 to 1. Okay, so that's your clockwise rotational bias. And then you have a counterclockwise rotational bias at 4.75 to 8 to 7 to 5 to 4.75 again, right? It goes circles, right? Counter rotating circles. Now, the interesting thing that I found, okay, is the trigger of the 3 and 6, okay? So the trigger of the 3 and 6 occurs, okay, at the switch points of 4 to 8 and 5 to 1. And that's important, okay, because 4 to 8 triggers 6 first, okay, and 5 to 1 triggers 3 second, okay, which is that's the nature of the retrocausality, okay, which is why they both hit in a different sequence, and then but they don't but they ignite at the same time and cross at the same time. Now, if you were to extend it out beyond just one waveform, okay, and actually have like repeating waveforms, what you would see is that anomaly appears to disappear, okay, meaning that the first go at it, the first cycle until it loops one time, it will miss, okay, but then it would appear that the 3 hits first before the mirroring switch, which is a whole nother story. We're not getting involved in that conversation today because there is a mirroring switch. But there was a key point. That's the establishment of that 4.75 mark. And the point is that if you looked, you have this ascending or expansion, right? And yet the 5 connects to the 1, okay? So when the 5 connects back to the 1, it's no longer 5 to 1, it's 5 to 10. Okay, now for this sequence to continue.
So hold on. You're adding 10 when you get back to the original?
When it cycles back, 5, it's ascending. And the sequence of ascending.
It's in a different layer.
Right. The nature of the ascending pattern here is doubling. So because it's in a state of ascension, okay, and it's 5, it's just simply doubling as it gets to 1 to 10. But that 10 has nowhere to go because the value is 1. So what does that mean? That means +1, which is, you're adding another basically point to there, which is 0. So what you end up with is this interesting circumstance of that third emergent vector, which is the +1, which gives the emergence of this superimposed second process on top of the rest. And yeah, that's the gateway. So because you end up with a 9 count system and a 10 count, okay, superimposed on top of it, the average median of the 9 and 10 coupled is 4.75. But again, retrocausally of this, okay, the cross point of the 4, 8, and 5, 1 vectors is at 4.75. So when things fall into these proportions, they immediately fall into these configurations, and that's the whole entire point. So it's like by virtue of the crossing is the third vector, but by nature of the return of the 5 to the 1 as a 10 is the supporting evidence of that +1 validity, right? And this is what you see. So what you realize is that this is energy flow, and that if you connect the points on this, right, you end up with a cube, and that's that's what you're dealing with. When you end up with the 10 count, you're more dealing with matter, okay, though, which is significant because why is matter 10? Well, because this entire mod 9 vortex equation, okay, is based off of asymmetric instability. So it reaches a state of balance, not equilibrium. Let's differentiate here, not equilibrium, right?
Okay.
It reaches a state of balance with disproportionate sides. Okay, so, but what that disproportion does is keeps it perpetual. So it's always in a state of motion. All right. But matter doesn't like that. Okay. Matter likes to be like, I've fallen into stability, therefore I'm going to coalesce. Therefore,
Right.
I'm going to attract and bond and stay that way. Right. Well, what ends up happening is when you switch to this 10 count, you now have this realm of stability that exists because everything goes into 10 and everything wants to arrange within it. And odds and evens all of a sudden make a difference where before they didn't, because 2/9 is not an even number. You get it? Like it's asymmetric to whatever it's being compared to. So 10 doesn't play by that rules. You fall into actual states of stability, of arrangement. And then, there's this coupling effect that occurs between the two of them because their commonality is the median of the two, which is 4.75. It's 5 in the 10 realm, and it's 4.5 in the 9 realm, but it's 4.75 is the coupled median. And what do we know about energy without matter? It doesn't matter without matter. What do we know about matter without energy? It doesn't exist. So it's this 4.75 coupling relationship between the two, the 9 and the 10.
So let me ask you this, Joe. Okay, we go one way in building the pattern, right?
Mhm.
And then the pattern builds opposite the next way.
Right.
And then is that the way you're going? So it's back and forth, back.
So this is what I didn't want to get involved in right now because it takes so much mental capacity to have to articulate this. But it's like, so this initial pattern is only the initial kickoff sequence. All right,
Okay.
That third vector kicks in and it's superimposed. But then because there's a reverberation, okay, between the two, I don't know how else to put it. Okay, there's a mirroring effect that occurs.
Yes.
Okay, and this mirroring effect then projects the same exact pattern of the 9 back onto itself inversely.
Right.
Okay. And then it does that back to the 10. The 10 does that. Okay, and then what happens is it flips. so it mirrors back inverse of itself, mirrored. Mirrors back, does the same, but then doubles and then unfolds, basically, like the flower of life. And then when you kind of have like the dimensionality at that point, you realize that all the geometries are everything that we see in this dimension when you take time and space and smash them together. You know, through the energy and matter coupling exchange.
So interesting geometry coils. When we build them, you build them 180 degrees out. So one goes one direction, you immediately take the other one and go the opposite direction, right? And then you pattern them like that the whole way around. And people normally say fields cancel, but they don't. They compress. When you get compression, it breaks free the ion from the electron in that coil.
Yeah.
In
So,
this coil,
so the reverse. So the answer to the mystic question is controlled decoupling of matter and energy.
yes,
You know, and bifurcation of the two. Well, what does that sound like? It sounds like exactly what we're talking about with Rav and Sean. You know, when you take your differentials and you put them on opposite sides of the equation, but then control the exchange rate. Now all of a sudden you're controlling the whole entire the whole entire thing. You know, that patterning and emulation, it leads to you know, a zone where it's that there's no coupling. You know, it's pure potential, right? And
right.
that's your exit point. That's your exit point for everything. That's where the energy comes. That's where you go if you want out. That's the whole 9 yards.
It's
That's
like
the whole
two sheath layers going like this. I can't do the bend, but they're bending against each other, and they're creating a focus between the center of it right here. I can't bend my hands the right way. They're making a C shape and another one, and then they're focusing light in between them, but then it's building back out the same way. It's Walter Russell.
Okay, cool. Now go back to the stupid Arabic numbers are more than what they seem like in picture.
This one?
Yeah. Okay. So what do you see inside of your magnetic field of the 8? You see that same exact C bent shaped thing, okay? And you realize that bend only happens for the sharp angle on the other side. It's just inverse. That's all it is. So what comes in square comes out circle. What comes in square comes out circle. You've squared the circle. You squared the circle. You squared the circle.
Got it. Okay. And John sees the same thing I do. He sees the guy on the bike.
It is definitely a guy. Listen, that guy looks like he's riding fast.
Yeah.
That's all I'm saying. Like he's riding one of them fast bikes.
Absolutely. That's what was his name? Lance Armstrong on some special stuff. That's what you got going on there.
Right, but you got to look at something else. Do you remember what I just said about the square and the circle, the square and the circle? Now look at opposite corners. What do you have above the D inside the 8? You have the square. What do you have next to it? You have the circle.
Yeah, well, I see that.
It's completely inverse. And this is made of all the numerals in their sequence of 1, 2, 4, 8, 7, 5, 1.
Huh.
Those are literally the numerals are in there,
Well,
and
let me
they follow
ask
the
you-
same pattern of in phase or whatever, or right side up, then rotated, then flipped. Okay, then flipped, then rotated. Okay, then right side up. They follow that same inverse pattern sequence in their orientation. So it's not like a fluke. You know what I mean? I didn't say put a curve in a 2 and put a curve in the bottom of a 5 and have them be, in inverse to one another. Like,
So interesting to look at.
yeah.
Yeah, in those coils, Joe, it's crazy because they keep building kind of the same thing and they think it's a big mystery, but once you figure it out, the idea is essentially to make it cancel, but you're not making it cancel because you can't cancel energy. But essentially, that's the point of those coils. The building one on top of each other that are opposite each other, it's a mirror. So we talk about Cosmonauts mirror. Remember both sides of it, the aluminum, and it shines, and then you're making the same effect. It's all about light and how it's perceived and how it mirrors one another. But then if you think about it, energy and light, they go together and they break to make your ion out. So you take your magnetodielectric, which is energy, which is colored energy because it's actually light, you know what I mean? How they see light. And then it breaks each other, right? So it's the same thing. How do you break out the 0 point? Because 0 point doesn't have light. So how do you get 0 point out of anything? It's to break it to get the light, the point where there's no light.
All right, check this out. A 3 is a sawtooth wave to a sine wave transition. And a 6 is just a 3 that went parabolic. That's all it is. And that is exactly what happens. A sawtooth, a sharp sawtooth turns sine, sweeps up, and then dimensionally wraps around itself with an output. That's all that is.
So funny. This is Tesla's hairpin circuit all day. Because the C shape, the line coming in, this is how he draws his capacitor, right? It's magnetodielectric into ion because you're compressing them and it comes out in one form. And then it changes the way energy works. It literally is that all day long. Because on both sides of your coil, when they mash up in each layer, that's what you're getting. You're getting 2 hot layers and a cold layer, hot layers and cold layers, all the way up.
So now what happens then to balance out the 6 that I was saying? Well, you have the 9, which is just the inverse of the 6. So and it's the interaction, okay, of the 3 and what the 3 became in becoming the 6. Okay, and then the 6 is then re-interaction with another 3. Okay, that then inverts the proposition to add to the stability. So it's a whole entire thing, and you don't have to do anything but look at the numbers to realize exactly what the waveform interaction would be if you combine this with that. So, the 3, well, that transition leads to 6, and then, well, as that's transitioning, if it interacts with another 6, that sawtooth wave, it's literally just going to add a second layer to it inversely because of that interaction with the 9. Just saying, but that's neither here nor there. The 369 isn't that important. It's the 9 4.750 negative 4.75 negative 9 that matters, because that's what forms. And that's the axis that keeps everything else in place. You get rid of that axis, everything falls apart. Then it's just the current state. Everything falls back into a current state. And I hate to tell you, but current states don't hold material together, and nor do they act as fundamental particles. So
Not current, no.
right.
Ian brings up a good point that it cancels the B field and leaves the A field, which is basically the electric, and which is correct. It cancels the magnetism out and brings in the electric, which is the ion. Is the electrical state.
Which is the point of the 8 encompassing the rest of the stuff. Because that reaction is actually occurring inside of that 8. That 8 is expansive because that 8 is that's the coupling field. That's the point where it went from, it was still ascending and it's about to start to descend. So, there's multiple points where the pendulum's up and about to swing down in this sequence is the point, right? So we know that, you know, the 9 is that same point where the pendulum's up, about to swing down, and then it does swing down to the 4.75, but the 8 is the same thing, you know, because the relationship with the 4, and the 1 is the same thing because of the relationship with the 5, except you got to remember when 5 goes to 1, it leaves that system at 1, but that 10 is now the swinging pendulum that's up. And how do they do it? They do it simultaneously in sync, right? Because that's the nature of that pattern.
Well, if you've ever built a geometry coil, what you're saying describes it perfectly.
Mhm.
I literally wind that into coils. So how do I say this? There's a pattern you follow the sequence, right? And then you immediately follow with a pattern of a sequence, but 180 degrees opposite of it. Then you follow in a pattern with the other one again. And when you build it different color coils, you see it. You get a gold coil, you get a red coil. You get a gold coil, you get a red coil. You get a gold coil, you get a red coil. Perfectly opposite, perfect geometries from one another. Then it shifts by 1. And you do it because when you shift, you vortex it all the way up and all the way down.
Exactly it. And this is why earlier in the chat, Pikachu something or other said something about Rodin coil and configuration. I don't have it in front of me, so I don't want to misquote. But the thing is, and I hate to ever be this way because I'm not that kind of person. Like, Rodin coils have a purpose, you know what I mean? But that's not the thing. You can't just build with wire the geometric thing that you want to make. You need to build with wire the vectoring patterns, okay, that you need the energy to travel to build the thing that looks like the thing. You know what I mean? It's I know it sounds so dick. It really does. But you can't just fucking build a torus and then be like, act like a torus. You know, that's because that's not what it does. It's dimensionally inferior and doesn't have the proper vectoring progression to do what it has to do. It has no opportunity. It's it's literal retardism, and I'm sorry, but fucking Marco Rodin is a fucking retard, and I'm gonna say it publicly. I don't care.
I don't agree with that because he's seeing energy flow and patterning his coil based on the energy flow. So here's the reason. No, I'm not disagreeing with that. But what I'm saying is when you put in the proper energy, because the Rodin coil won't produce it, when you put in the proper energy, then you see the actual result he was looking for. Now, just understand this. You put the hairpin circuit into the Rodin coil, what happens? And I've done this experiment several times. The thing, when you turn it off, will self-run for a little while afterwards.
Yeah.
Because it's creating entropy in the system because of the design of the flow. That's kind of the point, but you can't get it alone with the Rodin coil. You need another source.
This is what a Rodin coil does. And this is why I was so explicit about Marco Rodin a moment ago. All it does is it's a repeating cycle, okay, of expanse outward and contraction inward. Okay, and that sounds good, but it is not. Because what ends up happening is what Nathan does, which is in context of what Nathan does, a good thing, but in context of what Rodin's doing, it's not. It just builds out into diffusion, collapses, and then starts to go out into diffusion more. Collapses and starts to go out into diffusion more until it leaches all the capacitance that it could possibly pump out, and then it does the thing, you know, the little whoop 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 a little bit. But the thing is that that's not what that's not the thing. The exchange isn't there, and the resistance isn't there, and you're taking your parts and you're separating them, but at no sort of density whatsoever. There's no extreme energy density compression event. There's no interaction between the inner fields like that and the outer fields. It's all a diffuse reaction, and it's bust. Because all he did was, he's like, if this is the shape that I need my field to be, cool, you're onto something. Then I wind my wires that way. No, now you failed. Like, it's a vectoring equation. And there's a million ways to do it. And you can do it with a coil. You can. But the fact is, in my opinion, the real way to do it is the way that nature does it, which is with, using, using not only inductance, but using the relationship between the two sides in such resistance that they have to break through something, and that something to break through is a dielectric. And that's why Sean is so successful, and why all this other shit is kind of bust. It just is what it is, in my opinion.
I think the Rodin coil is an excellent one-to-one transformer. In every experiment that I've used it in, it stops the frequency from changing after it goes through it. Okay, so a one-to-one transformer, it's great at producing more energy than you put in. No, it doesn't do that. That's not really its intention. The changing it so that you can run it as energy flow instead, which is what I do, is more understandable in a way to see things properly. There's an absolute purpose for the Rodin coil, but it wasn't an over unity machine because it couldn't create that effect that you needed. So, but when you create it in the geometry coil, it becomes that because it's flat and because it stacks so many layers upon each other in the correct way that it shows that mirror, right?
Yep.
So that one got it right. And I don't know if Rodin did flat coils or not. I know he did the round coils. Each one of them is building upon the next to get to the next level, right? But you could have just done Tesla from the beginning and got the correct energy source that you needed. Not many people understand how he did it, though. They keep coming up with this $700, $800 contraption when you could do it in a $20 coil.
So, couple things real quick. Two things. So we have Ian saying, have I ever considered a pointing vector in a Rodin type coil? He thinks that the rotation effect that would continue to work, and like how that applies to Gerald's work, which brings me to my second point, which is Gerald's work. But yeah, I mean, that's a good point. So when you have, the field that a standard Rodin coil would produce, having a central axis pointing vector, through the middle, which is something extra and not part of it, right? Could potentially make a difference in changing the field dynamics. Okay, so there could be a secondary compression event but it's not part of the initial configuration. And I think that the idea there is, so you're onto something. Is there something you can do to make it possibly go a stage or two closer to what we're experiencing? Yes. But that's not how it's set up. Now, I don't know how badly I want to get, yelled at in my nightmares, but you know what? I'm here to tell you that Gerald's finest coils are not Rodin coils, not in the slightest. And the way that
Those are not Rodin coils at all.
not in the slightest. And Gerald's coils are based off of the same exact geometries and vector relationships that I'm discussing here. They're offset proportions.
Yeah, hang on a minute.
They're woven, not wound. And they're also forced into 3D geometry from a 2D geometry. So they literally, it's woven like a basket in the sacred geometry proportions, in the sacred geometry sequence. And then it's folded like this, like a cup. Okay. That's how those coils that he makes works, and they do. And I'm never there to take it away from the man. You know, like that's
So let's take,
that's what, you know, the Lord told him, and that's what he did. So
let me show you this, Joe. Okay, I'm gonna put myself on full screen real quick. This is my rodent coil. So it's perfectly wound, got everything in it. It's got the hole in the center like it's supposed to. All the way around, geometric form, one layer on top of the other.
it's beautiful. I'll give you that.
This right here is the pattern that I built as my geometry coil. And you can see the gold layers and red layers. And it is exactly one over the other, 180 degrees out, like Gerald's coil. One of the differences between this and Gerald's coil is he has multiple different geometries that go into it versus this is just a single geometry. And the difference in that is how you build your vortex. So I just want to make this point. When he does it, it's like this. A big ring, littler ring, littler ring, a littler ring, based on the outside dimensionality of his vortex. So he's literally curving it in.
Yep.
Why does that matter? If you look at the Russell scale, it's how each one goes as it goes like this down in the spiral. But the Russell scale is positive on one side and negative on the other. So it's two vortexes coming into one, like this, right?
Mm-hmm.
But Gerald's creating one half of the vortex is what he's doing.
Mm-hmm.
Geometry bigger, smaller, smaller, smaller. Okay, outside field dimension on one of his layers. That outside field dimensions is his third coil that he doesn't usually talk about because that's where he's putting the heat. Once he changes that to heat, the rest of it goes cold to the center. Every one of these ions are basically the center portion right here. That's what you're looking for. And I don't care if you're looking at the rodent coil.
You want a condensation of ions in there. Now, with the rodent coil and the difference between that and Gerald's coil primarily, aside from the vast differences with the geometries and such, is the nodal interaction. Okay. See, like Gerald's coil should really have very, very limited, if any, nodal interaction in those geometries. Whereas you're gonna have nodal points all over the rodent coil with the modular sequencing based on the frequency. So, it's in motion, but it's based on, nodular interference, and it's not the way to do it, man. Like, I'm just saying, that's an opinion, but that's not the way to do it.
Let me go further on this. When Gerald does his setup, he's pulsing back and forth between each layer. On each section of each layer is pulsing back and forth. So think about it dimensionally in his head. He's creating one vector, creating the second one. One, then the second one, then one, and the second one. So if you think about it, he's getting a double vortex with a node in the center is what it looks like in his mind when he's doing it, right? What's the problem with that? It's not.
It flips is what also happens.
Yeah, it's flipping back and forth, getting the action, but it's not giving you the vortex one on top, one on the bottom. That it's not doing. But what it is doing is it's compressing all the energy to ions. Why? What's so different about ion? Let me just tell you what it is. This is what confuses people. You're thinking about a ball of energy as an ion. It's not. An ion is simply the energy in the vortex. As soon as it creates a swirl, the energy that's there is the ion. That's why it's so confusing to people, because it's not the spinning necessarily, it's the energy of everything in it. That's what it's so confusing about it, because the vortex is moving, the energy in it is the energy, okay? But that means it can go completely cold on you, and it can freeze over, and it changes. It's not a ball. It's not the electron at all. It has a different understanding of the way it works. So when we look at the solar system, I just want you to think about this. The solar system is a ball, but then we're looking at it going around and around and around, right? So what happens is you have a pull on the ball. That pull is what creates every single vortex that goes on inside of our solar system. It is the reason for precession, the wobble of everything that goes on is that slight pull of that vortex going on and everything. That's why anytime it forms in anything that goes on, and why it forms in any circle, it creates a vortex within it. Why? Because we have a natural pull of the entire solar system that goes on. So when you talk about an ion, it always pulls towards each other. They all pull together, they all create a vortex, and that's where the energy is.
Nathan mentioned the heat being the counterpart, and this is so super critical, you know, and by adding the heat in, it makes it cold, you see, and this is the separation of the differentials. And this is why in the past, when we've talked about 0-point systems and how you have to have a secondary source for it to go into, so on and so forth, but here's the deal with it. The more heat you put in, the colder it gets. Well, here's the other thing. When you put a load on it, the more energy it pulls, the more heat it creates, the more heat it puts back, the more energy it gives. So then you plug something else in, and more heat it creates, the more heat goes in, the more cold it gets, the more the cycle goes. You see, it's load dependent. So
Yes.
to get your differential, the more you add in on one side to balance it out, to counteract it on the other, it pulls harder on the other. This is why, okay, it doesn't need to be at these immense energy density levels. Is because once you achieve the separation of differentials, the more differential you put in on one side automatically pulls the serpentine belt and the pulleys of everything, just simply pulling more in of the other side. So it separates it. And then that just accelerates the rate of exchange, you know, through the intermedium, like in the RAV's case, the RAV, you know.
Yeah, but that's what Rodin was looking for. When he did the donut, he was thinking the same way the people today think of it. Okay?
Yeah,
Like
I know.
Bob Greenyer thinks of it. Okay? They think they're creating the energy exchange in it, but unless you put the right energy in it, you'll never make it work that way. Because he's looking for the figure eight, but doing it in an incorrect way. Okay? It's like pulling a vacuum in a vacuum chamber instead of allowing the vacuum to happen inside the energy itself. It'll never give you the state you want, ever. It doesn't work that way. You can't arbitrarily put it in there. It must form it itself.
That's it. And that's what you're looking for, and that's what you're not looking for. You know, you could either be one of these people that thinks it's, you know, okay, well, if we want the plasma to spin in a torus, then confine it in a torus-shaped confinement tube and have it chase its tail all day long, and, you know, then you're like, well, how come we're not getting what we want? It's like, because guys, like, that's not what that's not the exchange you're looking for. That's not the exchange at all. That's the outside arrangement of, and it's like the part where the shit actually happens in the core, you actually isolate it out of your system. So how the fuck do you think you're going to do anything?
Here it is, Joe. Look. Okay, this is their reactor. They're pulling this, right? The energy's here. They're pulling this.
Right, they're keeping it out of the space where it wants to condense.
Yeah, they're missing the whole point of the energy. They're going, this is the donut shape. It must be there. No. It's in the core. All the energy's in the core. In every coil, no matter what you do, it's just like Bedini said, in a battery, when you hook negative energy to it, if there are little holes in the plates that go in, the energy pools in the holes. Why? Because that's where the energy is. That's where you need to find it. This is the big mistake of everybody. They think they created this donut and then it's going to give them what they want. They're not understanding the energy's in the center. It's not on the outside field. That's a plasma. That's the waste zone. That's where you see the light. You want the inside core. They don't even put it in the reactor. Matter of fact, they canceled it out. They made the reactor a donut like this, which is hilarious. You need the exchange in the center. It has to pass through the center in the exchange.
It blows my mind. It blows my mind. And yet, you know what? The thing is that everybody knows about Tokamak. Everybody knows Marco Rodin's name. You know, it's like this is where it gets like out of all that, and you know, the vortex math is cool. Like, you know, I'm not disagreeing with any of that. But he fails to realize even what the diagram is saying, and then he sees no correlation between emergent events. You know, considers the 3 and the 6 to the 9 the emergent event, but that's not even that's the secondary event. That's not the emergent event. And once you realize that the emergent event is actually the event that you contingent on this entire thing, and you miss that completely, and you never even realize what the implications are. You never realize that there's a superimposed 10 system on top of it. We observed the superimposed 10 system. Everything that we do mathematically is based on 10 math.
Well,
right?
Okay. Check this out, Joe. If you didn't understand that there was a cold side to it, everything that they do makes perfect sense. Okay, just understand this. If everything to you has to be hot energy, if you think in the way of the fire hose, which is your wall plug, right? If everything that you see has to be hot energy, you're going to base everything on that. So they think that only the one side of energy exists. They have no idea that there's an exchange in there. They don't see the cold side because they can't put it together in their head that it's there. So what do you get? You only get the hot side, which makes perfect sense of why they try to pull the plasma, because they think that's the hot side they need. They don't understand that there's another part to it at all. It's completely oblivious. And all of physics is written this way. When they do magnetics, that's why, because magnetics are hot. And they're only in a hot system. They have no idea what a cold system is. They have no idea what ions do.
But they agree with this in their own way, because they know that any hot bias is going to go into seek diffusion.
But they don't know that.
So, but they do though. They
think the sun is over unity. No, they think the sun is over unity. It's not.
And that's what Ian was saying a couple of minutes ago. Well, what about a pointing vector? Well, what do you think entropy is a pointing vector? You have the hot going into a state of diffusion, so it wants to move. But when you heat something up, you have it here. You know, it's not closed, right? But if you keep that hot, then it's always in a state of diffusion. So that heat always wants to move toward the cold. The cold, though, you know, there's always an intermingling situation that has to occur because they're drawn to each other.
So hold on.
Opposites.
A pointing vector of what? Here's the problem. Everybody says pointing vector, right? Of what? Let's just ask the question of what? Field alignment in a core of what? Hey, what are you looking for? They all talk about vector direction, right? But they're misunderstanding the point. It's the rotational value of the ion goes one way. As soon as it has too much compression going on because they're stuffed together, you have one that changes the direction in it. That's your vector direction change. Okay? That's what causes a field layer to go this way and this way. You have one going this way, one goes this way. Why? Because that vector direction changed. If you're looking at vector direction in any other way, it's going to screw you up because you don't know what the hell it is. They all say it like it's the smartest thing on earth. But then you ask them of what? Vector direction of what? What exactly line are you following?
Hey, heat itself, okay, is not propagation. Okay? Meaning that its entire diffusion, okay, is reliant on other differentials of the environment to accelerate the mix, okay, of entropy. Okay, so there's no, definite vector direction or point of emission propagation of just heat itself, except for the fact that whatever has caused it has caused a state of expanse, but that expanse isn't heat. That expanse is the energy release event. And I think that's where it gets lost, because if you just have heat and then you let it loose, it only slowly diffuses into the environment as long as there's nothing moving against it. It takes a long time for that to meld out. And well, again, that comes down to insulative properties also. It's self-insulating to a certain degree until something acts upon it. The environment only affects it so much. And when you have a cooler is the equivalent of a dielectric. The cooler only keeps stuff as hot or as cold as the forces acting upon it allow. That's it.
Yep. Hold on. The heat changes a little bit. We're going to take a high voltage line. We're going to put it into a transformer, and then we're going to put the mineral oil around it, right? The heat stays in the transformer. Okay? It all stays right there. Why? Because the heat is a amp thing.
Yep.
What happens is the voltage comes out and goes around, hits the metal, turns into amperage inside of it, creates a magnetic field, and then goes back out as voltage, but it can't escape. It has to stay in there, okay, in that area. That's why when you pull it out, you get a voltage and an amperage instead of just a super high voltage, okay? Mm-hmm. It's a simple conversion.
Yeah.
Okay. But the conversion never happens without the mineral oil. That's the problem. Without the mineral oil, there's no conversion because it turns to hysteresis and a complete loss.
Right. All right. Yeah. That is your insulative resistance. It's both containing the heat and allowing it to become transient. But that heat's only really a secondary effect of the voltage waveform as amperage, so it's acting as a pumping the friggin' crushing the waveform, and it's keeping it in that state of rather than allowing the crush to sit there and perturbate into diffusion. So it makes sense as to exactly why. It's because it's insulative and resistant.
Right, but let's minimize the heat now, and we're just going to use flux, magnetic flux. In the MEG, this is what they do, okay? They put the magnets in there, and that same vector direction of the magnetic field that's in there is cold. It's not hot anymore. It's cold. And it flips from one side to the other, creating an oscillation, okay? That's what it does, but it's all cold. That's why it freezes over.
Right.
It's the correct energy in the correct system. That's why they understand it that way, not versus the hot energy that we use today, which is all wasteful on purpose. They don't have to use it.
The whole entire nature of the way that we transmit energy is maintaining a current state. That's it.
Yeah, because
we use the current, so they maintain the current state.
Yeah, they keep us on hot energy no matter what. They don't want you to see the cold side. They knew it was there. I can tell you that right now. What was his name? The guy that did everything of the energy of Tesla, the short guy. Absolutely smartest guy in the world. I can't think of his name.
I know you're not talking about Ben now.
No. We're talking about Steinmetz.
Steinmetz, yeah.
Steinmetz saw it, wrote a book about it, and they GE would not let him publish it. He knew about the entire cold side of energy and how it works. And let me just say this. I need everybody to understand cold energy experiments are just ions. They're ions before they couple into magnetodielectric, which is a hot energy, which is the electron. And the electron is not a bubble. Look it up. It was they won an award in physics, right, for their experiment, and there's no balls in it. Not one.
It's just a conjunctive.
Won a Nobel Prize.
It's a conjunctive piece of a waveform. So it's like part of a waveform, basically, but it's the tumbling part, and like where the node and anti-node go and start to switch. That would separate the top of the waveform from the bottom of the waveform. That's what electron is, and it's those waves that pound at the at a conductive material, because conductive materials will they have electrons of their own, so to speak, to be able to smack into. So it tends to, and then they continue that chain of events, like pushing a thing of dominoes. It continues. Eventually it'll slow down, right? But that's why they just keep pumping more. Pump more, pump more pressure, more pressure, more pressure, and then it gets down the line.
Well, right here, Ian's right. Tesla said too, his electrons slowed down the process and got in the way of natural longitudes of the process. It actually did.
Sure. Yeah, aka sound.
Well, I don't think people understand this, Joe. We always talk about a pebble in water, right? How it makes the wave. Do you know most people think of waves that way when they think of the Earth? They think of the pebble in the water. Well, just hold on. Let me explain that.
Yeah.
But the Earth is a sphere. The spheres don't travel in waves like this on water. Travel like this. Boom, 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 right? That they misunderstand the waveform. The sun puts it out, boom, 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 boom. It doesn't go like this, like a wave in water. It looks completely different, and they can't make the geometry in their head work.
Well, here, let me complicate the geometry in their head a little bit more. You put your pebble in the water, and it makes your ripple 360 degrees out. But now, in order to imagine what it's actually doing, you need to curl it into a tube and then project it.
More than a tube, it has to be a sphere.
That's exactly what it is.
Their understanding energy is 180 degrees, not 360 degrees. They're seeing 180, and they're saying, this is what the energy does. They don't realize, no, that's 180 degrees, not 360 degrees. You have a misunderstanding in geometry. Stop using algebra geometry, okay? You got it wrong. That's 180 degrees, which means it's going to go like this, which means the wave is going to go like this on water, but that's not what energy actually does. When you have it at 360 degrees, it builds out like this. That's why nobody understands scalar correctly.
No, right, they don't, because if you take two 360 degree waveforms, where they're propagating out, like he's saying, if you take two at their points of intersection, you'll see that there's nodes and antinodes that occur at their interference pattern. And where did the water go from the antinodule, the cancellation part? Well, because it was in a state of scalar collapse in that time, as soon as it went into cancellation, it also collapsed out of cancellation. It rearranges itself. So that's what you see as the deconstructive and constructive interference simultaneously, because you could see where the water has gone down and you could see where the water has went up, and both the down and up is both lower and higher than its original ambient level. So,
I agree.
And that's the point.
But it's still 180. It's still 180 degrees.
But now here's the thing that really fucks people up. If you have one interference over here, but then it collapses all the way over there, you like, how fast does that happen instant?
Oh my God, Joe.
How fast
That's complicated.
How far could it be? Very far, could be. Depending on the resistance of the water that it's traveling through and so on. But in that case, you could get the deconstructive interference here, but then the collapse event there. They'll both appear simultaneously at two different points altogether, depending on the collapse of. People don't get it, but that's what Beard was fucking telling you, wasn't it? Because you have the cancellation event here, but if it collapses there, then it's actually going to take from the point of collapse, and then it's going to give to the point, take from the point of origin and give to the point of collapse. Get it? Or vice versa, depending on if it was constructive or deconstructive.
Yeah, but it doesn't collapse at the end, it returns. So let's take a pond, for instance, right? It goes in the wave, hits the edge corner, and then it returns, right? But if you take that and now you put little balls in there, right? All in the planetary formation, and the sun's in the center. Now it goes out, it hits the side and comes back, but then it hits every single ball and comes back. Every single ball puts out its own waves and then hits the wave over there and comes back. Everything is doing that all at once, but it's not just on a flat plane because it doesn't make flat planes, it makes spheres. So everything's in a sphere doing this inside of a contained container, right? And everything bounces and comes back, and then every single planet does it, every single moon does it. And you're looking at these compression waves that go on inside here. It's so mixed up, you don't have a linear line of light. You just don't.
It doesn't
work
happen at
that
the
way.
surface of interaction either. It doesn't only happen at the surface of interaction. I shared this example. I was sitting on the bank of a river, and there was water all around me, mind you, but I was rocking back and forth on this rock that I was sitting on. It was jutting out of the water, and the waves are going out exactly like we're talking about. And usual suspect stuff, some other stuff sticking out of the water. Okay, it's interfering with that. But then what you end up with over time is something wildly unusual. You start to see that the other points that it's interfering with fall into resonance
Mhm.
with that original sequence.
Is there
Okay,
a
and
harmonic?
they start putting out perturbations of their own. And then the weirdest thing happens. You start to see anomalous surface perturbations, okay, that are 360-degree propagation.
Because on the edge of
from
each
something
sheath zone,
under
they
the
build
water.
out they
From
build out
something
satellite.
well under the water. So something
Yes.
well under the water is then building up its capacitance of the wave repeatedly interacting with it. Now we're seeing it at the surface, but it's happening all the way down in diffusion, and that diffusion grows and grows and grows as far as its density and stuff is concerned over time. And if you do it long enough, you could put something into resonance that's below the surface of the water that then has a surface effect that's a 360-degree resonant perturbation.
Yeah,
This is how it works.
You're creating a satellite, which is a vortex. That's what you're doing.
That's it.
That's where the anomalies pop up, the crim vortexes. Hey, just so you know, the flat grid everybody talks about, I see this all the time. Why can't we go up in the solar system? You can, genius. You just got to point that way. The problem is they think that we live on this grid, that we're on this flat plane. Let me debunk this right now. Precession debunks a flat plane. Why? Because anytime that you look at it, the reason that you have any plane coming out of it is because the top and the bottom have wind, and then you get an equator, right? But it's not a flat plane all the way across, right? Think about it like this. You have precession, so the equator goes like this. You have a wobble. Well, what happens with the sun? You have a wobble. Every time you have a wobble, there is no flat zone. It cannot exist in nature. It is a zone that is a cone from the outside. We see this all the time in the RAV. The light spits out the side. They don't shoot in a straight line. They shoot out in a cone, just like this. Why? Because it has a wobble, it has precession. As soon as you understand that, you understand that immediately that flat plane they always talk about is total bullshit. It cannot exist in nature. It doesn't exist in nature. There is no flat line across the whole solar system. The reason planets are higher and lower is because of where the wobble is. They don't understand the words that are coming out of their mouth, and as soon as you challenge them on it, they go, where's the math? That's their big thing. And you can make up anything in math. I'm going to tell you that right now. I can put a bunch of letters together and multiples together and make it look like clean math. They lie to you. That's how they lie to you.
Yeah, you get tricked, with it. If you look at what you're hoping for the result to be, and then you look at your measurements,
Yeah.
you could just build something that bridges the gap between them. And I feel like, you know, even when I'm doing the simple types of things that I'm doing with simple arithmetic, okay, that shows the correlations, I often need to remove myself from myself to make sure that I'm not falling into that same trap, because, you know, I'm aware of it, you know, but like these other people, they don't look at it that way. They feel like if you have the two measures, you know, and then you could create the math to correlate them, then that must be it.
Yeah, Ian said, is it because the planet's orbits are helical following the sun? It's motion around the galaxy. Well, that's what that little pull is. That's what that vortex is. When we're going around the galaxy, the natural bubble that is our solar system has a pull, which is the vortex. That's why every vortex is created anywhere inside of our solar system. It has to do with that relationship. But then in the center of the galaxy, the same thing happens when you get to the cosmos. It basically pulls it in the same way. Yeah, there's a lot of things they leave out, and they try to give you the simple explanation throughout all these channels, and I've watched them all and think they're so smart about how things work, and they don't have it. They're missing half the equation. And I know this because every time you pull up GPT or anything like it, they like to tell you about how hot energy works, how the outside of the Tesla coil works, how all that works in hot energy, as it's the greatest thing. The hotter it gets, the more energy there is. But energy and usable energy are two different things. And that's the way they see it. They never see the cold side of it because they don't understand it. Physics does not understand it. For all I've seen, I've never seen anybody explain it because they don't get it. And all these cold energy experiments, cold energy, radiant energy, negative energy, they're all the same thing. They're all working on the principle of an ion. And once you realize that, it's game's over. There's a second side to energy, and they're not using it because they're now only one person has figured out how entropy might be creating gravity. One person. Do you realize that was the whole point? The cold energy inside, the hot energy on the outside, creating entropy on the inside. But she still didn't know how it worked because she's still describing only hot energy. She's only halfway there.
Yeah, I agree. The thing about being halfway there is that, you know, if you just complete the one cycle, you realize you weren't halfway there. You were only like really an eighth of the way there. But the good news is
To go in that direction.
the rest of it unfolds once you complete the first cycle.
Well,
You know.
okay. So if you show Egypt and the way they made energy back then, okay, they are light years ahead of us on how they created their energy because we are failing to do it right. Let me just say this. When you couple the ions together to create the field like Sean does, and you see the circle in the center and boom, 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 right? That's how they did it. That was their energy source. So when they create a UFO, that's a natural airplane to them.
Mhm.
You say, oh, no, it violates the laws of physics. No, it violates the hot energy laws of physics because it's cold energy. The energy you don't understand. So when you go back to ancient Egypt and I say I can use a vine as a wire, it's because I'm in cold energy. I don't need the heat. I need the heat as a draw. But that's what they told you with the light bulb. Why do you have a light bulb at the at the end of a vine? Because the light bulb is the pull. That's the hot energy. It pulls the energy through it. Completely different concept. They created coupling before we even knew what energy was.
They wanted something to fly in the air. And they're like, but things don't fly in the air, you know, generally, you know. They created an airfoil of a wing and then added a pressure potential to them, and then through an asymmetric airfoil design separated the air potential, you know, the flow potential into high and low pressure by just creating an asymmetric design. And then what immediately coincides with a high and low pressure differential is a high temperature and a low temperature differential, and a positive and a negative differential, and every other differential. So once you separate those differentials past their breaking point at the proper proportions, and then keep, because I'll tell you that the only reason a fucking airplane flies and it's not, okay, is not because of the separation, but because of the recombination. The answer is both. You could actually do it without the recombination as long as there's laminar flow between them. But what does that mean? Well, that means everything we've been saying all along, right? You're either going to create a torsion boundary layer where the two different things are flowing nicely past
And laminar
as they're
flow.
reintroduced, or you're going to stir them up into a mix that is separate but balanced, right? So they can diffuse in a non-violent way. Because if you take the high pressure and you slam it into the low pressure, like you get a massive expansion event if you don't do that. And then that throws off the balance of the first thing, and then you see it never happens. So if they're too stupid to look at it and see it and then apply it other places, you really can't help them. But like I said, from day one, we already have anti-gravity. You ever seen an airplane before? I mean, the thing is literally suspended off the ground. The only difference, and why we don't perceive it that way, is because of the differentials aren't set in a stable flow. They have to use propulsion to increase the differentials to the proper ratio, high enough to cause the lift. If that was just simply introduced as a cycling pattern amongst the wing, through the environmental conditions. Do you see where I'm going now? Now it's like they don't really get. You just have the environmental conditions doing that in relationship to the wing. All of a sudden, now you don't have to have any thrust in order for the lift to occur.
Well,
That's
the difference is in resistance. An anti-gravity craft creates very little resistance, where an airplane creates a heavy amount of resistance. It's the Mach layer. Anti-gravity has no Mach layer. The airplane does. That's the only difference. They're both in the air. They both fly. They're both sitting in between a bunch of, air molecules. The difference is resistance. That's it. It's the way you're making the energy work. You're creating more resistance in an airplane. But then again, what did they do? They basically took the bomber, right? Or was it the SR-71 or the bomber? I can't remember.
No, it was the B-2. They have inertial mass reduction.
So then they put energy on the outside to match the energy that's going on in the environment it's in. And what did it do? It went faster.
Right. It reduces
reduces the Mach layer that's going on, so you don't hit the boom. It reduces the buildup on the wings. It's as simple as that. They already knew what anti-gravity was as soon as they did it. As soon as they did it, boom, right in your head. They reduced the energy that goes upon it because they knew how to create the energy in the environment, which created the bubble around the wings, which made it go faster. Well, what do you think anti-gravity does? It's creating that same potential on the outside of it so that it slips right through it.
Yeah. Real quick, I want to give a shout out to Broadway. Very active in the chat today. Just want to throw it out there. Anti-gravity, wrong term. It's gravity manipulation. We know anti-gravity is that's the phrase. So that's what we typically use because it's just easy. But I don't even agree with gravity manipulation. Realistically, it's relative gravity manipulation, because
manipulating the gas in the environment.
Right. It's relativistic, right? And based on locality. So really, you're not manipulating gravity when we talk about any of these things. You're manipulating the gravitational relationship of, whatever it is, a craft we'll call, right? So you're changing the gravitational relationship between a craft and its ambient environment. And by
Well,
doing
hold
so, you know, that's how
And
you,
it, so-called anti-gravity creates gravity onto itself.
right.
It's creating
But
its own gravitational field.
so,
But it's important to know that because when you go out to space, the bubble creates its own gravitational field,
but
which
there's
means
still gravity. Yeah, the gravity is
it,
relative to your craft, though.
it creates its own environment.
Mhm.
Just understand this. This is why it's so special of what we're doing. It's creating its own environment. Regardless of where you go in space, it's creating O3 that turns into an O2 when you manipulate it in ions. It's creating its own environment. Just understand what that means for physics when you go out to space.
I'm gonna make you lose your mind. So is the wing on the airplane.
Around the wing, yes.
Uh-huh.
If they, okay, hold on. You could build up a static potential, but it'll fail. That's why you have turbulence. Okay, that's why airplanes crash. You have to manipulate it in the right way and create the ion in order for it to sit up and go flying anti-gravitational.
You got to remember that
Only the B2 does that.
yeah. Well, I mean they do it because they condition the environment in front of them to go around them to match. So there's a environmental. It's not their plane. The plane is part of it. That's only one part of the equation, you know. But I mean, it's the same. By the way, what you end up getting, okay, would be a subtle vibration, which whether felt or unfelt, being secondary to the point of the matter. The point of the matter is that there would be a vibration felt on the B2 spirit, right? And that's no different than the inertial mass reduction seen by Nathan in his Gravit Flyer testing. You know, it's the offset beat between the conditioned environment and that in which the airplane itself is in, interacting with one another, and then the felt oscillation of the craft and the environment, for that matter, outside of the interaction zone, is that slight offset oscillatory effect, and it's that exact effect that is the inertial mass reduction, because at that point it's doing a skip on the environment, it's skipping on the environment.
Yeah, but it shouldn't have any rumble in it in the B2. It should be smooth. When you have vibration, you have static electricity, which kills it. It's what turbulence is.
Right. I mean, the whole thing is that the B2 isn't, you know, as far as we know, you know, and anti-gravity craft. You know, the inertial mass reduction, though, works as we just said, you know, cumulatively. I think. What do I know? I don't work for fucking.
No, I think they're getting a slight taste of mass reduction.
I think so too. But what's that mass reduction based off of? It's based on an offset differential between your environmental condition and your induced condition on your craft, and the offset beat between it. That's where the environmental skipping comes in. What's skipping? Skipping is force, right? So there's an additional force being applied that would reduce the felt mass in relationship to, you know, the inertial effects. That's what it is, you know.
Okay, let me put it this way.
Like skipping a stone. Stones, you know, they sink except for when you skim them at the surface, because of the surface.
No, I understand what you're saying, but it's not exactly the way it works, I don't think. Give an example of the Tesla turbine. If you take aluminum and put it as a Tesla turbine blade, it wants to break the Mach barrier. Okay, why? Because it's pulling the energy into Mach, because it's using ions on aluminum. If you take aluminum and you wrap a coil wire around it of copper, the energy that comes out of it is ions. Gerard Moore improved this already in his experiments that he was doing. So if you take the Tesla turbine in the special UFO Schlosser shape that it has, every time you look at one of those blades, it's pulling an ion into it, so it wants to pull into Mach. What is the difference in a plane? It doesn't rotate. There's no field that rotates. There's no rotational value except for the propellers.
Talking about the same thing, believe it or not, but
it's different because you're confusing the directions of energy in a plane, but in a field bubble, you're not.
Well, the thing is that the field interaction, okay, between the craft and the plane at that point, it's occurring at a certain rate, at its point of interaction. Okay. And it's that exact interaction that I'm talking about. Okay. That is exactly what I was talking about. So we are talking about the same thing. It's just
Probably.
we're not seeing it the same, like the way that I described it was kind of very direct and saying, okay, so the plane is like skipping like a rocket. It's just an example. The idea here is that, you have these differentials. They're in attraction and repulsion, just like we've been saying all along, and it's that waveform interaction, that energetic interaction, that is the mechanism, therefore, of that offset differential between them that would be reduce the drag.
Yeah,
Anyway, get
the problem is they have competing geometries in the B-2 bomber instead of a unified one. That's kind of the problem. That's why it only gets partial.
Yeah. Well, they came out with a new one. So, yeah. It's not even like the thing anymore. I mean, it's still the thing, but like, you know what I mean? Like, they literally built that thing in like 1970. We're talking about it like it's some cutting edge shit.
Oh yeah. They had to learn their lesson by now, right? They definitely figured that one out.
Yeah. They should have never let one get shot down. We would have never known that it existed. It's when they tore the nose off the thing and they're like, what's this gold disc in the front? It doesn't look like radar we've seen before. Yeah. Oh, that's radar. It's really advanced radar. Oh yeah, and like F-18s are also, like the Growlers, they're also only jamming signals, right? Like, fuck out of here with this shit.
This is why some of the planes tried to smooth all the wings on it and create a more rounded edge as they do everything, because they wanted to kill the competing geometry.
Well, that was the downfall with tailfins. Tailfins are completely out of sequence for any type of flow pattern that would be advantageous to holding the bubble in. But what it does do is it gives you plane stability, right? Like on a plane. So you don't have to worry about your two-dimensional axes getting all fucking whiny and cranky on you and shit, Like, it makes total sense. But I mean, if you're looking for the next level of geometry, unfortunately, well, that's the thing that's got to go. Is your vertical surfaces. You don't want vertical surfaces if you're looking for a bubble.
See, here's the thing. If I wanted to create an airplane that I wanted to go slice through the environment, I would build a rotational UFO shape, right? That would be the first design I used to test the turbine, because the idea is to pull the energy around the craft faster, you know what I mean, than the environment. Well, no, because it would cut through it. It's like a pizza knife. You're cutting through it, right?
Yeah.
It's just different. That's what I would do first. I wouldn't think it's supposed to propeller on it. I'd be like, well, let's cut through the environment at a certain rate of energy, and then boom, right through it, right?
I mean, if I was making an anti-gravity device, it would have no moving parts. But we've went down that rabbit hole before, and I don't think we need to open that can of worms today.
I had to put together this presentation for Tesla Tech, Joe, and I wanted to give the example of what hot energy and fire hose was versus coupling. And I did an experiment a while back where I stuck like, oh my God, it was like 120,000 volts, okay, into the gravity flyer. Amazing the motors didn't fry. This thing just lit it up, dude. There was bolts of lightning everywhere. There's all kinds of ion wind going on. It's purple. Looked beautiful, right? Funnest toy in the world. Didn't do shit. It was a complete and utter failure. It was a failure to understand energy properly. But the way they worked their math and physics, it'd be perfect. The problem is, it didn't work for shit. There was no coupling. There was nothing. There was no understanding of energy. It was just basically fire hosing the thing. And I had to put that in my presentation of I did this like everybody else thought and failed.
Right on. Hey, Nathan, I hate to cut it short at a little over 3 hours today.
Oh, yeah.
But Yeah, I think it's almost got to be time.
Yeah. I just want to tell you this right now. I show this Alexi. For all of the crap he gets, he is one of the very few people that understand the energy coupling altogether. Very few. Okay, just no matter what you think of his craft, or it could be better. You know what I mean? He could have done this. One of the very few people that understand energy coupling right, just like ancient Egyptians. So, anyway, with that said, man, I want to say thank you out there to Darren, man. Awesome, brother. I really do appreciate it. I want to say thank you to Sean, who came on today and rocked it out, brother, with all his experiments.
Big round of applause to Sean, everybody.
Yeah. Joe, we're going to get into a little more of
Always
the
bringing the
369 and the rodent coil stuff after this next week. I think next week is going to be just super huge for everything, dude. We have that meeting coming up. I'm excited about it, dude. It's going to be awesome. Anyway, guys, thank you very much for hanging out with us, man. I really do appreciate it. And yeah, for the almost 4-hour show we did today. Thank you, Joe.
Yeah, awesome. Yep. Ian says he's going to Tesla Tech, so I guess he'll see you there. You know,
Oh, yeah, I'm looking forward to it.
I'm if anything, I'm going to be there in spirit. Maybe I'll convince the old man to somehow, patch me in on a call or something, so I could quasi experience something.
Yeah, dude, we're going to Tesla Tech, and it's going to be a shock to everybody on what we show them. I don't think they've ever seen anything like it. And my job is to present everything as a first, hey, this is what we actually know about the universe versus what we pontificated about with a thumb up our ass and are looking at a fireplace and a nice, comfortable chair. Sorry, my bias. Have a great night, guys.
Peace and love.
The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.